Yo, India, before I gotta go, you've seen Rainy Lake, yeah, from
Yeah,
Jesse.
yeah.
What are your contentions with it?
What do you
I
mean?
was just curious because you showed that to me. I've never actually looked at it before, but
That's the
from
one
the
where he
video,
takes he does a theodolite over the lake and he measures up from a nail. He put it the spike that he puts in the surface. Hold on, let me see. That's the one.
yeah,
I
it's like a
think
bunch.
that's the one.
Let me see if I have the website right here. They showed this to me the other day, and I was gonna ask you about it. I was trying to call your name over the live stream, but I guess you weren't listening at that time. I was like, India, I know you're listening. Where you at, bro? You might have been in the bathroom or something. I'd have posted up the link to the website in the side
Oh,
chat.
Bislin. Okay. Oh, that's just fucking. Hold on, I'll tell you time.
Look, I was watching the video, and you can still see clear to the other side. Like it looked like you can still see the shore on the other
Yeah,
side.
I think he went and did that on a windy day. No, this was done by this dude, George Hottanuk, who's passed away now. And I don't like talking ill of the dead, but he's a piece of shit. Anyway,
Oh, damn. Oh, shit.
he tried to get Brian Mullen, who was a flat earther. He was a. Have you heard of him, Brian Mullen?
Is that the same Brian on FED?
No,
Oh,
no,
I
he
don't
isn't
know him
in
then.
flat Earth no more because George Hottanuk tried to dox him and ruin his fucking life.
Oh, I see, I see.
So he left flat Earth because of this.
Damn,
Because
that's
of
fucked.
Hottanuk. He had a channel called Balls Out Physics, and he did a couple. He had a whiteboard, and he would do the equations for like landing an airplane and like all sorts of different things. Because he was like a not an architect. Maybe he was an architect. No, he wasn't an architect. He did some sort of structural engineering or something like that.
Let me
And
see.
George Hotnuke didn't like someone with professional qualifications. This is way back. This is way back. This is like in there, like 2018 or whatever. And he tried to report him and say that he violated his engineering oath. Now look in the chat this video.
I'll check it out.
I don't think that this is a reliable observation. Okay, let's just put it that way.
Yeah, exactly. So if you have a look at what Indio posted, and then have a look at what I posted just above that, right? So basically, it's even worse than Skunk Bay. Everything just jumps around like crazy constantly, and then they've cherry picked
Mhm.
a situation that kind of works towards their globe favor as much as possible, and then they've taken that image and then they put it into a computer model to calculate the refraction. They didn't measure any temperature, pressure, humidity, or anything like that. They had a computer model work it out, basically. So yeah, it's horse shit.
With absurd refraction values.
So
I
they
mean,
say
quite
according to the
honestly, as far as like a test, if I did this test, I would have said this was a failure. I would have said, well, the conditions weren't right. I've gone and done observations at the beach where it's just like it's the weather conditions didn't allow any conclusion to be drawn about what was going on. Like it's just a failure, and you go back another day.
basically they cherry picked images that didn't have as much distortion in them, and
Mhm.
then they said that means that there's low refraction on that day. and then they put it into a computer model, and the computer model calculated that there's a refraction coefficient of 0.27, and on a different day or different one, 0.18. And they said that it matches the globe. And that was how much refraction was present on the day. It's just reverse engineering, it's guessing, it's cherry picking, it's horse shit.
Okay.
It's just parameter manipulation. There's
3.91.
parameter refraction where you can just adjust that value without evidence, right? Hey, we did this observation, and this is what the globe geometry says it should be, and this is what it is. So there's X amount of refraction. It's freaking idiotic.
Yeah, like even if you have a look at this next screenshot, I'll just screenshot this. So on that same page, this is how they gauge that there's more or less refraction, which is this is retarded as well. Okay, so what they're saying is on the left image, it says clear image, low refraction. And then on the right, they say distorted image, strong refraction. But when we show them a long distance observation that's crystal clear with no distortion over a huge distance, that would require the most extreme refraction that you could think of for it to work on a globe, they'll just say it's refraction, even though in their Rainy Lake test, they say, oh, it's low refraction because it's clear. That's how we know it's low refraction. They're just clowns. Double standards of evidence. Yeah.
Yeah, for sure. Because the only thing that I could see when I was looking at it myself is that whole distance to the horizon, as we could still see clear to the other side. Some of the other frames, so it doesn't comport to his side at all. I can see like people like walking around on the other side, like for a few frames.
If you
I
have a
can
look
get
at
it.
the time lapse that Indio posted, you can see crazy miraging effects happening off in the distance.
Yeah.
Right? You can't say that this footage is useful for anything. It's useless footage. It's just blurry. It's not even over a long distance. And it's blurry, it's shifting all over the place. There's miraging effects. Right? I guess because they invested so much time and energy and money and whatever into the experiment, they kind of had to come up with something, but really they should have just thrown it in the bin and said, yeah, there's too much variation in the weather conditions to make a hyper specific claim that it matches a globe.
You can see miraging in the foreground in that video, not even in the background.
Yeah, when I brought that up to the Globers, they said, oh, the miraging's off in the distance, so it's not happening where the observation is. It's just off in the distance, so we don't have to worry about it.
Oh, okay. But it's also happening at that little green pole that's in front of the first marker. You can
Yeah,
see it bouncing
I
up
see
and
that.
down. Like, what are you talking about?
Let me see if I can get that dude standing
I
on the
dare them
opposite
to say
side.
that, and I dare them to say that in front of me. It's off in the distance. Like, okay, well, what about the bendy cranes? It's way up in the air. Right? It's not at the horizon, which is miles away.
Okay, there we go. Finally got it. I'm gonna have to mark this up because you barely see his ass. Okay, sorry for my
What is
bad
there?
circle, but
What is the line of sight distance on this?
well, for the video, it's 3.91 meters. Distance to the horizon should be at 7 kilometers.
Yeah, but what was his actual line of sight? Like, can you tell? Like,
Oh, I don't know. So I'm saying, but that dude, it's like all the way clear on the other side.
with his
I think it's a dude. I don't know. That's my was my only contention with it when I first looked at it. So I wasn't sure what you guys' thoughts were about it.
The amount of effort that they've gone to on this website to try to document it with all of these equations and It's
Dude,
ridiculous. They've put so much that they're just trying to confuse people with large amounts of data.
yeah, like look at GNS, GN, GNSS, ECF, elevation in GOA data. None of that has any bearing on anything. It isn't going to help you determine anything.
But yeah, Lats, you can use this against them, right? If you take this screenshot, and I'll put it in the side chat. 1 second. Right, so it says on their page, on Walter Bislin's page, that if it looks like the left image, then that means there's low refraction, according to them. So if you can produce an image that destroys the globe that also looks, semi-clear like that one, then by their standards, that means that there's low refraction.
Uh, I see. I
Therefore
see.
debunking the globe. Yeah.
You know
Wait,
what
have
they
you guys talked
say?
to Jesse about this? Oh, my bad.
Oh, I was just gonna real
Oh, go
quick. You
ahead.
know what they say? If you can't dazzle them with brilliance, baffle them with bullshit.
You got it. That's the plan.
Yeah, that's awesome. I like that.
That's an old cowboy saying.
Awesome.
Why didn't they do a flat Earth refraction correction? Would there be
Hey,
a
what does
refraction?
Jesse have to say about this?
Oh
Did
God.
you guys talk to him about it? He's like, he should be here soon. He's normally on around this time.
He's in my
Yeah.
DMs right now. He's trying to
Oh,
analyze the that long distance infrared picture where you can see all the peaks of all the mountains. So he's now
I
he's
see. I
asking
see.
me, "Oh, do you happen to know exactly which peak here is the globe buster?"
All of them.
It's like all of them.
Yeah. Well, I'm trying to tell him that it's where's the geometric horizon? This is a geometric horizon test in a sense. Where's that's meant to be at 120 miles or something like that. Basically, where the water, you can still see the water.
Yeah. It should end in the water.
Yep.
Yeah, so if you like take the point where if you like go on Google Earth, take the point where he was at, and then use the circle tool, right? And then extend it out to where the horizon distance would be. That circle, the entire line of the circles in water. It's not on land.
Oh yeah. How do you put the circle radius thing down in Google Earth? Is that something that's simple to do?
Yeah, you do the measure, right? Oh, how you put it down? Well, you use the
Yo, how
measure
do you add the
tool.
circle? Yep.
Okay, yeah, you have the measure tool, right? And you have path, line, and polygon and circle. Use the circle, and like as you're extending the circle, it'll have the value, the radius value. So that would be the horizon distance. You just use that as the radius of that circle. And then once you click it again, you'll have an option of saving it. Then when you click save, you name it whatever you want, circle at frickin' Canagoo, and that circle will be there.
Awesome. Thanks.
It'll be a permanent fixture. Because according to them, the horizon's a circle, right? So
Have you guys seen Jesse's 3 mile laser test also?
only 3 miles. What's
Yeah, he
that?
sent me one the other day. Um, he said that when he lowered his camera's elevation from 3 miles away, it would get blocked by supposed Earth curve. So I
At
told
3
him that
miles?
next time, yeah,
Okay.
but I told him that he should have gone up also because I'm
Is it on
curious if that
water?
was just a divergence of the beam. Yeah. So I sent him this, and I want like what your thoughts are on this picture that I made, this poorly drawn picture. Because if he was to go up and down, so also go up in elevation until the laser disappears, then it should be shorter if you were to measure that divergence.
The problem with doing it at that distance, beam
You know what I
divergence
mean?
at that distance, the spread of the beam
Yeah.
is going to make it more visible, not less visible. The only thing would make it less visible would be a convergence.
I don't know if this picture makes sense though, but I wanted him to also go up
Doesn't make sense to
as
me.
well. Yeah. Because if you were to go top down, it should be a shorter distance for the laser because it's being blocked by a supposed Earth curve than if you were to go left and right. You know what I mean? I don't know. That's why I was going to ask if this picture made sense or not.
Oh, we know he had the laser pointed into the fucking water. His experimental technique, I'm not confident in. I mean, Over the Fence has said it perfectly. Every single observation he has taken comports with a globe. He's not stupid. He's
Yeah.
lying. You couldn't do it by act. You couldn't do it even if it was a globe. You couldn't get that.
Yeah, he also contradicts himself, right? He holds his laser test to completely different standards than our laser tests, right? He says that the FE core test, right, the laser's right up in the air. He said it could even be 80 meters up in the air, and the only reason you're seeing it is because you're seeing the light up in the air. Right? It's not actually making it to the target. You're just seeing like right. So Indio, here's a challenge for you, right? You're not allowed to laugh. No one's been able to pass this challenge so far.
Okay.
So this is what I did. I asked Jesse to draw me what he thinks is happening in the 40-mile FE core laser test from a side view. So here's what he drew.
Oh God, I gotta see this.
These two images.
Dude, that's the world's shittiest laser. Well, you put a screen door in front of a laser, so it splits into a bunch of different beams.
Yeah, basically.
No, did he saying that the lasers are
Well,
flat?
some of the
So
FE core ones, you can see the reflection in the water. How does he fit that into his diagram?
Well, I was showing him the 21-mile Great Salt Lake one with the laser, and he was trying to tell me that because you can see the reflection in the water, it means that there was an inferior mirage taking place.
What the fuck? What?
I said that's just a normal reflection because it's a still calm lake at nighttime. It's like a mirror surface.
Dude. It's not inferior mirage, dude.
No, definitely not. And if it was an inferior mirage, then that's even worse for the globe side. That means the light would be bending upward, and it would be even worse for the globe. Great, because for that laser to be seen at that height from that distance, it would have to be some crazy, extreme, magical, divine downward bending, perfectly with the curvature of the Earth type of downward bending, not upward bending.
Have you ever seen the Flatlanders video?
Heard of it?
The Bonneville Salt Flats? I didn't realize that they drove down. So this Highway 80, it's Interstate 80. It goes all the way across the Bonneville Salt Flats, and they got like 5. So they went out one day, right? And they did like 5 measurements, like 3 miles, 5 miles, 7 miles, 13 miles, and then they got out to like 30 miles, 30 something miles with a blue laser. And then they go back and then they do it, they replicate it with like a green laser is like 37 miles. And not only do you see the laser, you can see all the streetlights. It's called I think the place is called East Wendover, Utah. And you know that you ever seen that picture they take where it shows a highway that's like curved? I'm sure you've seen it. And they say like
Yeah. Mhm.
yeah, so they went to that place. So where that highway is, that's where they did the laser test on that highway.
I
But
hate
it's
that
like
image.
it's more than just one, it's a
Ridiculous.
whole bunch. I didn't realize they did that many. Hold on, I'll post a screenshot of the map.
Has anybody in here ever actually observed a laser taking a parabolic arc?
No. Only in a drawing.
Oh, dude. That's freaking hilarious, man.
I did actually see that once. It was on a game called Worms Armageddon back in the like late 90s.
No good game.
So that's in that image. Is he claiming that the beam is diverging because of refraction? Like that's an accurate representation?
I mean, he never sent that picture to me, but I mean, I'm
Oh,
assuming.
okay, sorry. Okay.
I'm sure that's what he meant when he sent it. What he sent it to you, right, DJ?
Sorry, say what?
Oh, that picture. He sent it to you, right? Were you guys talking about it?
Which picture?
The one
Oh,
with
the
all the
blasted
lasers.
laser.
Yeah.
The one with all the side view picture. Wait, so hold on, let me check the
Yeah,
chat.
that one with all the red and yellow, I assume lasers, right?
Yeah, that's just one laser. So yeah, this is so
Okay.
he
Oh,
he was
okay.
saying so he was trying to debunk the 40 kilometer FE core laser test, and he was trying to say that maybe when you see the laser, it's not hitting the target. Really, it looks like it could be 90 meters up in the air, right? As it would be on a globe, and so I asked him to draw me a side view of how he thinks the laser beam is making it to the observers that are 100 meters below the curvature of the Earth at point B, and that was his picture. Basically saying that the laser's like doing what you can see in the picture, and that's how the light is getting to the observer, right? Which contradicts what he's telling Latz is happening with his laser over the 3 Mile Lake, because he says once he gets below a certain height, you can't see the laser anymore.
Mm-hmm.
Because it's just blocked. But he's saying that you see the laser even if it is blocked in the FE core test, right? So it's a complete contradiction. I don't know if you're listening, Jesse, and you want to defend yourself if I've misrepresented your argument.
Well, I mean, like for the 40-kilometer one, you should have to be 90 meters in the air. That's 120 something feet. How many feet is 90 meters?
It's three times 90 meters. I mean, yeah, 3 times 90, basically.
Yeah, 295
So we read
feet.
it-
That's
yeah,
like
so
that's like a
we-
28-story building, right?
Yeah. Yep.
Which is freaking
Yeah,
pretty
he
tall
says
building.
it could be that height, he said.
Okay. So why don't we observe shit like this happening all the time? Why don't you just wait for the right weather and see over a hill? See what's on the other side of some hill. Right? When you say, like, if it's the same logic, right? If refraction's creating these mirages, because that's what it would be a mirage. It would be an apparent laser, not the actual laser, right? If it's creating a mirage where normally you could only see it from 300 feet, but you can see it at ground level. That means that you should see this in nature all the time. That means you should be able, like, on the other side of a 300-foot hill and see the bottom of the other side.
Yeah, exactly. Yep.
That the hill would look flat, even though it was a hill. No
Yep,
one has
that's
ever done that. No one ever, like, holy shit, dude, I thought that was a flat spot. I was gonna pedal my bike freaking really fast, and then I just, holy crap, I'm going uphill. How'd that happen? No one ever's done that, right? Like, imagine the Tour de France. They're like, speed up, we got a straightaway, and it's a giant hill. And they're like, damn, we bore ourselves up.
Yeah, it's just we thought it was flat. It looked flat, but we forgot about the refraction.
Yeah,
Really,
exactly.
we got to go uphill, 200 foot up this hill.
I know there's the Boston Marathon, right? And there's a whole section of that, which is when you come through Newton, they call it Heartbreak Hill, because a lot of people, they don't make it up it. Right? So they're running up the Heartbreak Hill, like, hey, there's flat going all the way to Boston from here.
DJ, I have a quick question.
Uh-huh. Yeah.
In that really long laser test, they did like a bunch. Not all of them were a hit, right?
They hit on all 5 of the tests that they documented in there, but there was also certain days where they couldn't use the test because the conditions were,
I know you're
creating
doing.
miraging
He's
effects.
confusing Balaton. I know what he's doing. You're confusing Balaton with Lake Isamir.
Oh,
There's a test in Lake Balaton where they did not hit. The laser died.
how do you guys explain it when it's not a hit? Is that, well, there was because you said there was miraging or refraction, and that's why it didn't hit. But then the Globers say the
couldn't.
reverse, right?
No. In Lake Balaton, they had problems aiming. They didn't have, like, they were still aiming by hand. They had I should say, they had an aiming device, but they still had to steer the aiming device manually. Like, they had a stepper motor that would move it around, but they still had to do it manually. The device they used at Isamir was GPS targeting. So they didn't have to aim it manually. You understand that when you say you shoot something 10 kilometers and you move that half a degree, that's moving hundreds of kilometers at the other, hundreds of meters at the other end. It's very hard to aim at these distances.
Yeah. Because when it doesn't hit, if you say, well, it didn't hit because of the atmosphere or miraging or refraction,
When do they not hit?
Well, DJ said that there was occasions where it didn't hit, right?
At Lake Balaton, they were shooting at an actual target. An actual target. They had a green laser and a blue laser. They hit with one laser and not the other. But they had problems aiming it, which is why they went and did it again, because it was like super cold. Like, when they went to Lake Balaton, it was like freaking negative 10 degrees or something. They picked the wrong. They wanted to go and do the test over a frozen lake at Lake Balaton. Lake Balaton is very well surveyed. That was the other reason. The elevations of the what do you call it? The perimeter of the lake are well known. So, because it's been surveyed, it's almost like an exemplar for geodetic surveying. So that's why they went there. But when they got there, the lake wasn't frozen, but it was freezing cold. The lake is usually frozen by that time. So they couldn't go to the surface of the lake, you understand? So they had to be on the edge of the lake, above the water, which had its own problems. Their plan that they made kind of fucked up, and they tried to compensate. Their actual goal was to do I think their goal was they were going to try and do a 50-kilometer shot. But they couldn't, because they couldn't get down to the surface of the lake and the weather was too cold. And it was not exactly clear.
When it was too cold, they did it with a green laser, right?
Yeah, and then the green laser broke.
Yeah, I did found this information. Green laser sensitivity, green lasers which use a frequency doubling crystal are notoriously temperature sensitive. So it depends of the weather conditions. They cannot achieve the target maybe because of that.
Okay, so now that you got updated on the information, what do you think?
Well, there was the cases where DJ was talking about where there's the 5 that they published, and then there was a couple that they didn't, or they missed because.
No. Right. I remember somewhere in the documentary they were saying that they went on some days and that there was like visible miraging effects, inferior mirages, or something like that. So they went back and did it on a different day when they had more stable conditions, because you wouldn't want to go and do tests on a day when you've got obvious miraging happening in the distance, right? You would want to pick a day where you've got better conditions to work with.
We were just talking about this 5 seconds ago.
Yeah.
Yeah, nature doesn't care about your experiments. Sometimes you go out and the conditions don't exist for you to do a reliable experiment.
So that's what I'm saying.
Jesse was saying he went through it and he said that they did attempt it and failed, though. They didn't pack it up and go home. They actually tried and missed.
Which one was that?
I don't know which ones he's referring to.
Yeah, I'm sure he doesn't either. I wouldn't be hitching your wagon to Jesse's statements, dude.
Yeah, my bad.
I'm just saying, dude, we're just talking about that too. Jesse and the truth they're not on the same page. Hold on, let me go get the FE core document real quick. I haven't looked at it in a while.
Yeah, because I've seen a strong refraction, like photos of it, where there's vertical compression, but there's not clear warping or anything like that, but there's the compression aspect. So it looks clear, but there's still strong refraction.
You mean like stooping, where it compresses the things, flattens them?
Yeah, and I think that's in the 0.75 range of refraction. Very strong.
Well, no, that's not how you would work that out, right? It's just a stooping effect, right? If you have a look at the guy that does the Black Swan oil rigs observations, BLSM B69 or whatever he's called, he goes out on different days, and some days it looks like they're stretched out, it's called towering, and then some days it looks like they're all squished, like little squished oil platforms, and Yeah, you get a whole range of different effects on different days. But that doesn't mean there's a specific refraction coefficient just because you have something that's stooping.
Yeah, I think that because the globe is made of, like, the globe model has so many different facets of it. One of those is what we call refraction. Like, these events very rare. You go to many, many, many days, and you can like hit these targets with the laser. Something on the globe models has to give.
Yeah,
And it might just
we've
be that
got
maybe these things are more common than we thought. Maybe that those refraction days are not
Maybe
rare,
we
but
can
just
first,
uncommon.
maybe we can first find one. I mean, because we have the laser test, maybe we can pull one up and then talk about the specifics of that. And you try to work what you're saying into the data that's already there instead of just speaking generally, right? Doesn't that make sense?
so look, Dr. John D is an expert in lasers, right? He's a PhD in spectrophotometry, and he's gone out for years actually doing real tests in the real world. And he's this is the challenge we always have for you guys, right? If you're claiming that there's this crazy downward refraction all the time in all these laser tests, because we got so many laser tests now, and for them to all work, you would have to have this amazing divine refraction that somehow bends the laser downward around the curvature
And
of the
follows
Earth.
flat earthers around. Follows
And
flat
it
earthers
follows,
around to make
yeah,
their lasers work. That's what it does.
yeah, it's conspiring against the globe and working with flat earthers, this divine refraction deity. But look, this is the challenge from Dr. John D and from basically all of us as well. Find us, and I'm not saying it can never happen, right? But find us the laser test where the lasers bend down, because Dr. John D said he's done years worth of laser tests using different spectrums of light, different weather conditions, daytime, nighttime, different seasons. And he says sometimes it can bend up a little bit, sometimes it goes perfectly straight. He's never seen it bend down. Technically, it probably could happen, but you guys don't have any footage. It's most definitely not the normal that happens. And he goes into extreme detail about why the temperature is what controls the optical density gradient at that altitude. And he explains that the normal is that the temperature gets cooler as you go up. Okay, and that's the reason that the laser sometimes bends upward a bit, more so at nighttime. But he said he's never seen it bend down, right? So if you're saying that it's common for lasers to bend down, then it should happen all the time. There should be tons of footage of it. I've got tons of footage of them bending up or going straight, like Dr. John D says happens, but none of them bending down.
You know,
should find that.
This is funny. You guys are gonna get a kick out of this shit. It's on the same. This is definitely in the same vein. I've never seen a laser bend, any demonstration of a laser bending down in the air ever. Not once. No one's even proposed how they would even show up. Though I've seen the bending up. But this is funny. So, how they claim they measured the speed of light was a guy named Foucault in, I think it was 1846. So what he did was he took a light. I don't know what the light source was. Some fucking candle, who knows? And supposedly he took this light and he used a reflector and he beamed it through a half silvered mirror, and he had a big wheel that had teeth, and he beamed the light through, like, in between the teeth, right? But the wheel's spinning, right? And that light goes through the gap in the teeth. 16 kilometers is the optical path. Bounces off a mirror, comes back, and goes through a gap in another tooth, right? And then it goes to another mirror, which reflects it, and he can see, like, when he spins the wheel, that the light's flickering. But when he gets to a certain speed, the light isn't flickering no more. That means it bounced off the mirror 16 kilometers away, came back, and then hit one of the teeth so that he can't see the light anymore. Understand?
Mm-hmm.
So how the fuck did he get it between between the teeth if there's refraction bending the light all the time?
It's not all the time. Well, I posted this is from 124 stations over 10 years, so this is the largest set of data I've seen on refraction, and a positive number on this graph means it's bending upwards. A negative number means it's bending downwards, and there are plenty of samples in both of them. You can see that
Where did you
tip.
post?
He's parroting Ruhif's graph that he made himself. That he says that you could use this, right? So basically, there's like 100 and something weather stations, and they got different readings of the
Is this their
refractive
cinnamon
index.
controls radiosonde data?
I'm not sure
Where they
exactly.
calculate the refractivity?
They use the Sitter equation, I think, or something like that. And Ruhif's made this chart. So Ruhif's claim is that every single observation above a certain altitude perfectly aligns with the globe and is 7/6R, and his chart proves it or something like that. Hey, are you going to
Where's
share
the
the
source
chart?
of
or
the
what,
data from which he
Betty?
made the chart from?
Yeah, I'm going to bring up Ruhif's video. I haven't looked into it a ton.
Is it old or new? 'Cause I might have already
It's
seen
new.
this.
Well, we don't even need his
It's
further
pretty new.
claim. Just that
But
these
listen,
measurements were taken.
he can put any refractivity crap he wants. Okay? He can say this refractivity results in light bending down. Great hypothesis. Now show the data demonstrating it. You understand how that works? That you can have a theory or a hypothesis of how it bends based upon some other theory, right? Hey, we have a theory of how refraction works in air gradients. Great. Awesome. And this is all our refraction data. Super. Now correlate that to actual measurements of light bending down, bending up, bending in any direction. Because without that, you don't have the experimental support. This is completely theoretical. That light would bend down because of this data is completely hypothetical. Science is empirical.
This is stronger than this is 10 years of data from 124 stations. This is stronger
Not
than
data
just
about light bending down.
Is the Earth flat? Really?
Stop, dude. Dude, can you wait your turn? So it's not data about light bending down, is it? They didn't take any measurements about light doing anything. Right? That
Who are
debated,
you talking
Daddy?
to?
Yeah, the Earth is flat, dude. Go outside, take a look.
Oh, that's real. Oh my god. It's totally flat.
Yeah, it is. That's why everybody used to
Because
think it was flat.
if there was a single example, so if I did have like an example of a laser bending down, would it
It's not a
obliterate
fucking sugar water, dude.
a non-sugar water? Yeah, but like out in the wild,
Yeah,
would it
that would be
like?
cool if someone
Would you agree
demonstrated it.
that
It would be awesome.
Would it obliterate the whole like your guys' laser test approach? Like you would not want to do that
Once it's
ever
not a
again?
trend. But it would be a good start to demonstrate that it's even possible. You understand that that the globe Earth has hooked your wagon to something that they can't even demonstrate is even possible. All they can talk about is that it's hypothetically it would happen, but can't demonstrate it ever actually happening. Maybe you might want a data point that shows, yeah, this is possible. Physically, in the physical reality.
Yeah.
But just demonstrating it's physically possible, okay?
Globers aren't the
That's your
ones like
starting point.
obsessed
That doesn't mean that's what happened in a bunch of observations.
Globers aren't like obsessed with this, but yeah,
But
like there's
listen,
the data.
hold on,
really
dude.
good.
Listen.
That's
There's
good
a
data.
difference between demonstrating its possibility in that in any given experiment, like Fe cores or the one at the salt flats, that it actually happened in that experiment. You understand? But you haven't even demonstrated that it's even possible. much less that in any particular experiment that it's happening. That's how far away you are. Right? You say, hey, hey, we did this test. Well, the light's bending down around the curve in that test. Well, how do you know that? What's your evidence for that? Well, like, because of refraction, light can bend around a curve. How do you know that? We're not even at that
Know
part.
what?
You're not even at step one.
Well, because we have common measurements of there being a.
No, you don't. Then post them. Post the measurements of light bending down around the curve.
There's the refractive gradient.
No, that's not.
The
Then you
negatives.
didn't. Okay. Tell me how much the light bent in that.
It's actually more common from this graph.
Tell me how
for it
much
to
the light
be
bent in that.
in the
You
negatives
said you
when
have
you're
measurements of
lower
light bending
altitude.
around a curve. Show me in that refractive in the measurements of the refractive index. Show me where they measured light bending around a curve. They didn't, and you know it. This is just desperation.
It's just in the definition of like negative refractive gradient or positive refractive
It's not
gradient.
in
Like,
the
that's what it
definition.
means. That's just what it means for it to be a negative refractive gradient.
No. Refraction is the electronic properties of the molecules. It's how fast light goes through that medium. That's what refractive index is. It's the ratio compared to vacuum. So if you have a refractive index of 1.3, that means light goes 30% slower in that medium than vacuum.
Okay.
Really
Well,
simple. That's what's being measured, but that doesn't entail that the light is curving down. That would be your hypothesis that if we have this refractive index gradient, then light would curve down. That's a hypothesis.
That's how it's defined.
It's not how it's defined, okay? It is not.
Hypothesis is what?
His hypothesis is that if there is a refractive gradient of air, that light will bend down. That's a hypothesis. It's never been demonstrated.
No, I mean hypothesis on like what thing? I didn't.
I'm not even talking to you, bro. I'm talking to the beta daddy. He wants to abandon empiricism, which is the foundation of science, and adopt ideas and theories to determine what reality is. That's not how science does it. You have an idea, you have a theory. Okay, go out, do the test, and demonstrate that that's actually the case. But you can't, nobody has, no one ever will, because it's not the case. Because if it was the case, it would have already been done. It'd be easy to show, especially the fucking amount of refraction you guys claim exists.
So, whose party support a flat Earth?
Look, dude, what makes you think? Look, let me ask you this: if nobody told you the Earth was a globe, would you have figured it out yourself?
Nobody
You know,
told me this story.
Nobody told you. Did figure it out yourself?
I could say.
What's up?
Dude, what's the problem with answering this question honestly? My goodness.
He went. I think his buddy in his room freaking freaked out. So he went on mute. It's a tough question though. So since you're here, Sesu, we're going to ask you. You're the next step. Have you ever seen any demonstration of light bending down in air?
Negative. That's why I hate refraction. And I mean, Reductio or Debate Daddy or whatever, he's saying that Globers are not obsessed with this. Like hell, they're very obsessed with this. This is the only retort they can give to the observations, however many hundreds or thousands of them that we have. That's the thing that they continue to use is refraction. And so we go, okay, can you demonstrate that refraction does the thing that you're claiming, which apparently is make the Earth look flat in some form or fashion? It's always bending light down. And we get nothing. We get crickets. We get tables of pre-assumed or presupposed amounts of quote unquote refraction. And it's really becoming pathetic. I want you to demonstrate for us that light is doing what you say it's doing. It's not happening.
Well,
Yeah, we
I thought
basically get everybody believes this hypothesis is true, therefore it is. We defined it that way. That's silly. That's a silly fucking argument.
Well, certainly
I can
the
define
definition
you
would
as a
come from some
fucking
kind of
furry fucking mammal with a tail. That doesn't make you a dog.
well, there
right.
are laboratory experiments, but you guys didn't want those, so where you can affect the refraction coefficient, but it literally is how it's defined. Is the positive refraction means that light's bending upwards, negative means it's bending down. I showed you 10 years of data showing that it can bend up or down. It's actually more common for it to bend downward at lower altitudes, and you guys just reject that. So I don't
Reductio.
have
You show the evidence that we're rejecting.
Yeah.
the like aquarium laser experiment where it bends down.
With the sugar water. What specifically did Indio tell you about? We want the demonstration of the laser or whatever you want in the air doing what you say it's doing. The thing you're going to go to is sugar water? Come on, dude. What are you doing
Okay,
here?
but if you're rejecting that like a negative refraction coefficient
How
means
is it
it bends
equivalent?
downward,
How is it equivalent?
it's just how these things are defined. So it's not a hypothesis.
How
It's
is it
just
no? But
how
how is that the tank of sugar water equivalent to it happening in air?
it's not equivalent. It's a demonstration.
A demonstration of what?
It's a demonstration that if you can create a refraction, it can bend downwards.
Dr. John D tears this apart in his videos. I don't know if you should need to watch the video, right, where he does this, right? He tears apart the sugar water test with the laser that Mick West does, okay? Because the situation at the atmosphere when you're shooting a laser over a body of water would mean that you would have to tip that fish tank situation upside down, okay? Because the optical density, right, where you have a higher optical density, that's where the laser is going to deviate towards. Okay, so when they have the more dense sugar water at the bottom of the fish tank, when they shoot the laser through it, it bends downward towards the higher optical density portion of the medium. That's the opposite of what we have out in nature when we're doing a laser test over a body of water, right? The normal is that the temperature controls the optical density. It's the primary controller. It's in all of the definitions, in all of the literature, that it's the temperature that's the primary controller of the optical density. The temperature gets cooler as you go up. It's warmer down lower. So you would have to flip that around, right? That's why the lasers don't bend downward, because they're bending upward, because the colder air has a higher is a higher refractive index than the warmer air that's down lower. It's very rare to get the thermal inversion where you have that cold air trapped below the layer of warm air. The normal situation is that it gets cooler as you go up, right? And temperature controls the refractive index according to all of the definitions, right? Do you need a definition?
Yeah,
Or grab
here's the
me
other
one.
problem. Here's the other problem. Sugar water is a sorry, somehow I got disconnected. Sugar water is a molecule, so it changes the polarization of light as it passes through it. You know that changes of polarization of light create a torque. Yeah, a torque, dude. What happens when you create a torque on an object that's moving? Takes a curved path, right? The other problem of You're going from air, where the laser is, into glass, into the aquarium glass, and then into fucking water. You're actually going through 3 refracting mediums. This is nowhere near an equivalent experiment. It's a parlor trick.
Where I'm getting confused is what you think a positive refraction coefficient or a negative refraction index
Listen,
means.
look, they're not measuring any positive or negative refraction coefficient. They are doing a calculation. They're assuming that there's a spherically symmetric temperature grade or refractive index gradient, and that ray would take a curve, and that if you shot a ray through it, that it would take a curved path. And then they take and compare the radius of that ray to what they say the radius of the Earth, and that the coefficient is the difference between those two things. Okay? It is completely an abstraction. You didn't know what the refraction coefficient was, did you? What do you think 7.6R means? A ray that has a radius, if it was a circular ray, that's 7.6, the radius of the Earth. So they just assume that the Earth is 7.6 larger, and they do the straight ray calculation. They're not actually modeling curved rays. And this is why it's bullshit. All you have to do is demonstrate laser light curving down in air. You guys claim this is happening 24 fucking hours a day. You should be able to go out and do it right now. Do we got to get a GoFundMe for a laser for you?
How much do these lasers cost?
Dude, use any laser. Doesn't even matter. Dude, it's so absurd that we've been talking about this.
Yeah.
Lasers don't bend down, dude. There's laser light shows. There's fucking goddamn military equipment. None of them account for bending down lasers. There's the Fuzel experiment where he freaking measured the speed of light. There's no way he could have freaking did that. You know what he assumed? That the light was going straight. For some reason, light only bends down when you look out and you see that the Earth looks flat. Every other time of the day, it's not bending down, and they're just straight rays going all over the place. What about long distance shooting? What about 2,000 meter frickin' rifle shots?
If you want to hang your hat on this, and then they're actually go and acquire such an observation, it's going to really, really suck to down that hill.
Actually, isn't this the hill that you're
Why doesn't
dying
it
on?
already exist?
Yeah, that's the better question. I mean, you guys have had all this time to demonstrate the refraction that you're claiming exists, and yet you've yet to do it.
10 years
Where
in.
is it?
Debate bed, you think anybody's tried? And failed? Which you were mentioning, trying and failing? And by the way, I looked at the FE Core document. They didn't try and fail. So when they did a live stream, they were doing a live stream. They live streamed one day, and when they tried to do the 12 kilometers, they failed. They did it the next day, and they didn't live stream it, but they did record it, and it's in the document. So Jesse told you a half truth.
Yeah, I think the other thing he mentioned, you let me know if this was a half truth as well or not, or to what extent. He said they didn't actually level the laser properly. They just moved it up and down until they got the hit, and they said, "Oh, it's a hit, stop," meaning they were like kind of just moving it around randomly.
So you think that somehow misleveling the laser is going to allow them to shoot at 40 kilometers and magically hit a camera 4 feet off the ground instead of 400 feet off the ground because they didn't level the laser right?
Well, did they? Let's say it was angled up, like how even on a flat
Look, you
plane.
tell me how they could have configured the laser of any manipulation of its level to hit a
Yeah,
target.
if it were angled up and it
Yeah.
still hit even on a flat plane.
If it listen to what
Yeah,
you're
so
saying,
saying
if it was
it looks
angled
like that.
up,
It works like this. If you're able to move your laser around and then you hit the target and stop and you leave it on that target, you are now level all the way across that, because you can't level a laser with a bubble level and be perfect on the other side at that distance. You have to be able to hit a target. Once you hit it, you're there. You're not away from it, that's for sure.
okay. First
Now
of all, what
that's
Jesse said is false. They
now
did
that's affirmative
listen.
consequence.
They leveled the laser. There's pictures in their document of the fucking laser level that they leveled the laser with. So that claim is false on its face.
Wait,
Okay?
whoever just affirmed the consequent, do you understand that's what you did?
Don't get hung up on that, dude. Let's talk about the fact that, let's say they pointed the laser down, right? This is going to be
Or
devastating
up,
for you.
or any direction.
Any direction. So let's say they bent, they tilted the laser down. Okay. How come it's not running into physical Earth curve if it hit the target 200 feet below? I mean,
Well,
my goodness, man, this is a concession on your side.
Well, it depends on geometry and how the light's curving. I've thought of it if they angled it down, that maybe the light could be bending upwards and it doesn't actually hit the lake, bends
I
upwards
don't
and can still hit the
care
target.
about your musings. I want to know where the physical Earth curve is blocking out the laser if I tilt it down.
If you're tilting it down into the Earth, it would hit the Earth at some point, or it would have to curve
Right.
up.
Right. So if they hit that target, there's no Earth curve in the way, no matter how they tilt it.
It just depends on how much.
Well, show me.
I don't know what their measurement. I don't know what the angles were.
Okay.
Yeah, you
Did
do.
they publish their angle? Did they publish it?
Yeah, you do. You know the radius of the Earth. You know the height. It's all published. Are you telling me that you haven't even looked at this? Are you telling me that you're getting all your information second, third hand from Jesse, Path of Light, who doesn't know the Path of Light?
I didn't watch the full video. I watched part of the video where they got a hit. Well, I don't know if they published the angle. So if it was angled up, that's impossible according to you guys, on a globe or a flat Earth if they angled it up.
Why are you talking about angling the laser up? What was the claim, that they angled the laser up and somehow hit a target? Why don't you actually go ahead and look through the documentation and watch the videos instead of taking your information from Jesse, Path of Light?
Sure, someone DM me the document that they made about it.
In your mouth. I don't want you blabbering at me about what people know. I want the evidence itself, preferably measurements of curvature. Do you have any of that?
Wait.
So you don't have it, do you?
Wait.
You don't have any evidence that the Earth is a sphere at all, do you?
Wait. You're asking about the evidence, or you're asking about the proof, basically?
They're basically synonymous at this point. Evidence or proof, I'll take either one. What can you show me other than just running your mouth?
Okay, when a ship moves away, the pod.
Okay, so it's just going to be you running your mouth again. I can see that now we're talking about ships. We've made it first full circle. We went from gravity to Eratosthenes to pilots to flight instructors, and now we're at boats on the ocean again. No worries. Can you prove to me that a boat disappearing bottom up has anything to do with the curvature of the Earth? The best way for you to prove that is to have the curvature of the Earth first, instead of saying, well, I see stuff disappearing bottom up in the distance, and therefore I assume and affirm the consequent that it's because of Earth curve. Give me the curvature of the Earth first, then we'll talk about why the boats disappear the way that they do.
If the Earth was flat, the whole ship would just.
So now you're going to make an assumption that if the Earth was flat, it would do a certain thing. Meanwhile, you're not actually giving me any evidence for the Earth being curved. Is that right?
Circular shadow. Observed
Okay, so
since ancient times by people like Aristotle.
Right. So you don't have any proof, any evidence at all that the Earth is curving in any way. Not one bit.
I'm giving you all the evidence. You're saying I'm good.
No, here's the weird thing, friend. When you think that making the claim is the evidence. No. The evidence supports the claim. So in some form or fashion, can you give me measurements of curvature of the Earth? So that way, when you make a claim, it's backed up by the measurement. Can you do that?
Bro, this is going nowhere. You don't want to believe the
No.
Earth's sphere. Okay.
Okay, so you just want to believe that the Earth is a sphere. You don't want to provide any evidence. You only want to make the claim, and then the claim is the support of the claim. And so you really don't know if you live on a sphere or not. It's just something that you hope is true. Is that about right?
Let's nullify this. I have no evidence the Earth is sphere. Okay.
Okay.
I have nothing. Wait. Let me answer. Let me fully answer before I go. Let me fully answer. Don't interrupt.
Okay.
Just like you said that I have no proof the Earth is sphere and the Earth is actually flat. Just as you're saying the Earth is flat and you're telling me no evidence. But so
Ladies and
each
gentlemen,
of us, so each of
we
our
got 'em.
arguments is nullified. But let's say how many people believe there's flat earthers, and according to flat earthers the equipments of the aeroplanes and each and everything is made. 99.9999999% people believe the earth is fair. Even if 0.0000001% believe earth is flat, let them say they are flat, because every equipment is based on the earth's sphere. Every GPS system, satellites, telescope, each and everything is based that earth is basically a sphere. So even if minute people believe the earth is flat, let them say, because otherwise we are going to
Nothing is
provide
based on a sphere, though. Nothing that we do in
every
reality is based
we
on
will
the
provide
sphere.
you
We don't use a
we
sphere in engineering. We don't use
we
a
can
sphere for
provide you
flying.
billions
We don't use
we
a
can provide
sphere
you
for
billions
driving a
of
car.
examples
We
that
don't
earth
use
is
a
fair,
sphere
but you
for
don't.
sending television signals through underground cables. We don't use a sphere for any of that.
Is basically sphere. The whole humanity will give you billions of example proof and every scientific.
Not one. There's not one example of anything that's ever been designed that requires a sphere. I design shit all day long, and this globe is. I never think about that. I try to stay
You believe
real far away
you
from anything curved. I got to have shit
bro
flat and
you
level when I
bro you
build
can
stuff.
bro you can believe the earth is flat. And
Okay, so to wrap it up, our friend here is still claiming that everyone, 99.999 onto the who knows how many decimal points, believes that the Earth is a sphere. And
So like
yet,
1,000 people, basically.
yeah, right. And yet, he failed to give us one evidence, one proof at all that there's any measurement of this
Well,
thing.
that just proves that there's only like 1,000 of that are geniuses in the world. There's only 1,000 of us. We should all stick together.
I agree. Meanwhile, we've got some of the resident anti-flat earther trolls in here. We got Brown Recluse. We got Hung Like Tic Tacs.
Hey guys.
You got to be fair. A lot of the systems that we work off of do, kind of rely on that foundational presupposition that we live on a round Earth.
What do you
Terrific. Which one?
Hold on
agree,
a
and
second. I want to. Why are you saying that?
10 more seconds. I agree that, like, when I'm working in my workshop, I want shit flat and level. But when he brings up like GPS, when you use Google Maps to go from A to B,
My God.
a lot of what we rely on has that presup.
No.
No, Google Maps is
No,
flat.
this is what look, bro. There's the way it works, and there's the way you think it works. That you believe, like Google Maps uses a globe or a sphere. They display it to you that way, but mathematically it uses a cylinder.
So my understanding
GPS
is that
mathematically
Google Maps
doesn't
uses
use a
Mercator
globe. Hold on.
projection.
GPS doesn't use a globe. It uses a reference system called Earth-centered, Earth-fixed, which is a plane. So there's the way things actually work, and then there's the way you believe they work. And they don't match.
Can you source that claim that GPS works off of
Uses
the,
Earth-centered, Earth-fixed?
Earth-center, Earth-fixed?
Yeah.
I've never heard that
Dude,
before.
it's well known, dude.
And just to be clear, my understanding is, like the cylinder thing, my understanding is that the Mercator projection that Google Maps uses is based off of a globe Earth. Because if we did not, if we were working off of a flat plane, whether it's Apple Maps, Google Maps, or anything in between, they wouldn't need to use a projection. They could just use a scaled down version of what is reality.
What's being projected, though?
The round Earth onto a flat plane.
The coordinate system's being projected, the latitude and longitude coordinate system, which is not the Earth.
Just to be clear, I think you're
not,
mixing two things.
No, I'm not.
GPS is distinct and different from when I'm talking about doing a road trip on Google Maps.
Okay, listen, brother. It's projecting the coordinate system of latitude and longitude. Okay, that's in this. Those coordinates are in the sky. They're not on the ground, and this is easy to prove. If you want to find your latitude and longitude,
are we talking about Google Maps or are we talking about GPS?
Google Earth, the Mercator projection is a cylindrical projection of the celestial sphere.
Can you source that claim?
Jesus Christ! Find your latitude and longitude without looking at the
Source some of your claims. I'm only holding you to the same standard.
I can prove my claim with just simple things. It's really simple. How do you find your latitude and longitude without seeing the sky? Using exclusively terrestrial, using exclusive. Cite my claim. Okay, longitude is the position of the sun relative to what? Look, bro.
Come on, why are you over talking me?
You want me to source my claim of what latitude and longitude are?
No, I made it very clear. Now I'm speaking English. Please, somebody sanity check me. When you tell me that the Mercator projection that Google Maps uses is based on is something to the effect of a cylinder, I'm hoping you can source that claim.
That the Mercator map is a cylinder? That is a cylinder projection?
Yes. Yeah,
Jesus Christ,
what you're
dude.
claiming, please source it.
Fitness skill is does that also help? Like I know it says specifically mischief for the heists. I wonder if that
Ella, you are so far away from your mic, it sounds like you're in a different state.
So here's something you can do. Go on Google Earth and take the path tool and try to draw a circle around the North or South Pole. See what happens.
I definitely didn't actually sell stuff. I don't want to actually sell my pottery, then I run empty pottery. They're not good quality. My employees don't get money out of it. These aren't worth it.
Mercator projection is a conformal cylindrical map projection. Post in the chat. You could have just looked on fucking Wikipedia. So here's the funny thing. How are you arguing anything about maps when you don't know anything about maps?
Map that
How are you arguing anything about maps when you don't know anything about maps or GPS?
The arguing. Sorry.
That's why I said there's the way it works, and there's the way you think it works. So in your head, you made up they're using a globe for this stuff,
To be
but
fair
they're
to
not.
me, don't change subjects. Just stick on this one topic for a second. So I'm trying to understand this. A conformal cylindrical map.
Map projection.
And of course, like you'd agree with my premise that we wouldn't need a projection if we indeed lived on a flat Earth. We
That's
could
not
just use
true.
a scaled down version of a map.
That's not
Okay,
true.
I'm okay. I don't wanna change
Look,
subjects,
bro,
so
that's
let's
not true because the Earth has topography. So you don't even know that
I
basic
agree.
fucking fact. So if you had 2 points on a map, right, and then you had a mountain in between them, the distance on the map wouldn't be the land distance, would it?
It wouldn't be like my walking distance, but it would be as the crow flies. Correct?
Yeah. So what are you mapping? Were you mapping the terrain? Are you mapping a projection? Is it orthographic projection? Is there a perspective projection? Like, what are you talking about?
We're talking about Mercator projection, and you're talking about the cylinder.
You said a
that the
flat Earth
Mercator
map
is-
wouldn't fucking need a projection. That's bullshit.
Hey, slow down. I'm seriously trying to understand here. This Mercator projection is a conformal cylindrical map projection.
That's
I'm trying
right.
to
And Google Maps is the Web Mercator GL. That's what it's called. So Google Maps uses it's what Google Earth uses. What they do is they take this little coordinate grid system, which is a spherical coordinate system, which is in the celestial sphere. So we know the coordinates is the 0 is the celestial equator. That's your latitude lines. Where that thing appears to be above the horizon is your latitude, and where the sun is, which we know from the time of day, relative to Greenwich Mean Time, that's your longitude. That's what the coordinate system is. It's in the sky. It's not on the ground, right? And so they take that coordinate system and then they project it.
I'd love to understand you better, but you gotta slow down a little bit. So my understanding is that maps, they have a disregard for GPS. Like, throw that out the window for just a second, because it doesn't matter. While maybe the Mercator projection is like conforming itself around this concept of GPS, not all maps have to do this, right? And so,
GPS don't
without
work the
getting
way
into the
you think
weeds on lat long, say it again.
GPS doesn't work the way you think it works.
Okay.
Do you know what let me ask you,
I'm
do you know
asking
what
you
a
to throw it out the
coordinate
window.
transformation do you know what a coordinate transformation is?
I don't off the top of my head.
Okay. So it's a mathematical
move, right?
operation that'll take the coordinate system, like say Cartesian coordinates, and convert it into another coordinate system. So this Mercator projection is a different coordinate system. They did a coordinate transformation to make this map. So you can
So just to
preserve
be clear,
angles, you
if
can
I'm on a
preserve
sailboat,
distance.
if I'm on a sailboat and I have two different maps in front of me and I'm crossing from,
You
East
wouldn't use a
Asia,
map.
I have a Mercator.
You wouldn't
Okay.
use a
Well, I'm
map.
trying
You
to
would use
understand what you're
celestial
telling me right now.
navigation. Nobody's sailing the ocean with a map. Was it turn left at that wave?
I didn't want to derail you with the ocean example. I was trying to understand like a real practical case where I'm using this coordinate translation.
It's transformation.
What did you call it?
It's a coordinate transformation.
transformation.
You transform from one coordinate system into another. So
the only
GPS
reason
is
why-
in a Earth-centered, Earth-fixed. So if you have a GPS receiver, it creates something called a RINEX message. In that has 3 coordinates. Those 3 coordinates are on a plane. It does a coordinate transformation and converts your coordinates that you see on your phone into latitude and longitude. It converts them. You see it as latitude and longitude, but GPS isn't getting any lat long information. It's a conversion to make you feel better that the Earth's a globe.
A conversion from what to what?
From the tangent plane, it's called up, down, east. Those are the 3 coordinates. That's X, Y, Z, Cartesian coordinates on a plane. But it's called up, down, east.
From what to what?
From that, from the GPS, that's the coordinate. That's what your receiver gets. Your GPS receiver gets that. Okay. And then it converts them based upon the Z into, when it does the coordinate transformation, the coordinate transformation assumes that everything is equidistant from a point, right? The 3,959 mile radius. So when you have your Z on the plane, it'll conform it to that radius. Understand? This is just a mathematical operation, dude. They could do any one. They could fucking pick any possible fucking form, shape. We're very good at this. I mean, we make video games, right? All the models you see in a video game, the models are wireframe of triangles. But the thing you see is the texture skin. The skin, which is, guess what? A rectangle. That they wrapped around that. They wrapped it around the wireframe.
Triangles. Yeah.
Yeah, they wrapped it around it. Right? We're very good at doing this. It's basic like differential geometry. You can project any surface onto any other surface. It doesn't matter. But what surface is being projected is the point. The original surface that's being projected is the celestial sphere. There's no doubt about this because you can't find the latitude and longitudes without it. If you had just an endless cloudy day, latitude and longitude wouldn't exist as coordinate system. Whether the Earth is a globe or not, there'd be no way to use it.
Because it's always cloudy. So like you can't use lat long on Venus.
How would you find it? How would I find, say, I want to know when I get to 23 longitude, 45 latitude. How would I know when I'm there? What do I look for in my environment? You can't. There's nothing to look for. Now, if you could see the sky, you whip out the fucking celestial navigation manual and figure out when certain stars at a certain time cross that position.
But you just said that that we had clouds. So now we're getting rid of the clouds to be able to.
No, I'm just saying you can find them with the stars. You can't find it without the stars.
And you can't see the stars with clouds in the way.
Yes, exactly. You can't find your coordinates. That
okay,
I mean,
okay, and I get like that's based on a spherical, the celestial sphere, blah blah blah.
Yeah, a sphere of
Going
infinite
back
radius.
to when I said like try not to change the subjects on me. We've gotten into the weeds already when I asked you that.
It's very important.
When we talk about the
these
Mercator
details are
projection,
important.
when we talk about the Mercator projection being technically a cylindrical projection,
yeah,
I don't think I can get past, and I think this is a big barrier for me personally. I don't think I can get past this idea that if the Earth was indeed flat, we would be much better off having a flat Earth map rather than this projection baloney that we're always dealing with. Am I wrong?
Oh, really? Then you must really not like the globe because it's like a triple projection.
What's a flat Earth map?
Well, you get what I'm saying, though, right? Like if we indeed lived on a flat
No, because
plane,
all maps
it
are
would be
flat. I
much-
just don't know what a flat Earth map is.
Okay, but you'd agree that while the Mercator projection is projecting into a flat plane, it's depicting a cylinder. It's depicting a spherical object.
No, you got to measure a sphere
No,
to be
it's
able to
depicting a
depict a
cylindrical
sphere.
object.
Say it again.
It's depicting a cylindrical object.
Okay, so is the Earth cylindrical?
Do you think it is?
No.
Well, Google. Well, your original argument was it works. So if it works in a cylindrical projection, it must be true, right? Yeah.
My argument originally is that if, like we were talking earlier about like the practical uses of being on a spherical.
Yeah, that's an it works argument.
When I'm in my workshop, I don't care about how curved the Earth is. I want flat, level stuff. I'd agree with that. But the reality is that when you go to the grocery store that you've never been to before and you put it in your GPS, you're using Google Maps, Mercator projection, or Apple Maps. I'm pretty sure. I don't know what projection it uses, but I know that Google Maps uses a
Same thing.
Mercator projection. And it would be better off for all of us, my understanding, is if we used a map that was just scaled down to reality. Why use a projection? Why use a projection?
Because the uniformity of the stars. Convenience.
Never heard this.
So we have something called the International Terrestrial Reference System that all the governments and everybody got together and said, hey, we're going to come up with an official freaking coordinate system for the Earth. And that's the one they picked. They could have picked another one. You know, they used to use different ones, right? They used to use ones that didn't assume the Earth was a ball, that didn't use any ball in it. It's called the Public Land Survey System and the State Plane Survey System. See, it's very funny that when they actually survey the ground and actually try to match it to the celestial sphere, that it doesn't match. Why? In like the funny thing that you said was, why use all these projections? There's more projections than you know about. I only told you about projection of the celestial sphere, but to get the ground coordinates, there's another projection. There's two more. There's the reference ellipsoid, and then there's the geoid. So there's two more projections. In the reference ellipsoid, do you know that plumb lines curve? Do you know what a plumb line is?
I know what a plumb line is, but
yeah, do you think they
was the
curve?
projection?
Do you think
What
they
was the
curve?
projection?
Do you think they curve?
No.
Well, according to the globe, they have to curve the plumb line, dude.
Well, what was the projection that they were using?
Well, what they're projecting is surface measurements, and they're projecting it onto a
No, no, no.
reference ellipsoid.
I'm sorry. I thought you were talking like the distinction between Mercator versus, you know, I don't know, some other projection map. What are you talking about?
Okay. Okay. There's two ways. There's geodetic surveying and astrogeodetic surveying, right? One's a
Never heard.
coordinate system based upon the stars. Now you can measure the land and try to match that up, right? If the Earth was a sphere, it would just match up, right?
100%, yes.
Okay, but it don't. And they know it don't, because they have to curve the plumb line. They have this thing called the reference ellipsoid. Do you know what that is? Because they don't measure a globe and they don't measure a curved surface, they do something called, they have this reference ellipsoid that they project their land measurements onto, right? But then they can't project it directly. They have to say that the plumb line's curved because it doesn't match up with the celestial sphere.
What's a practical way that I would end up having to use this ellipsoid?
Google Maps. Google Maps uses the WGS84 reference ellipsoid that is projected into a Mercator map. Well, web Mercator. But the thing is that WGS84 reference ellipsoid is mapped to, well, filtered. Well, first it's filtered through the geoid, and then it's mapped to the celestial sphere. Like I said, there's 3 projections with the globe at least. Probably another one. There's also something called a telluride height, but I'm not too familiar with that.
And what's the mainstream, like not argument, but like excuse for why we have these WGS something 484 ellipsoids? Like
I don't know. I don't know what their argument was.
I know that I've seen.
They decided back in the 70s that they were going to switch because they had what was called the they had the what they used the Clark ellipsoid, and then they switched to the WGS84 reference ellipsoid. Now in America, at
What was
least,
the
the
one
Clark
before it?
ellipsoid is based upon the NAD27 land survey, at least the section of North America that we're on. they had a everybody doesn't use a WGS84. There's a custom datum in Australia. There's actually 100 datums, depending on where you live. They have different datums, different scaling factors.
This is the status quo as of like today, that we're not all using the same system, this World Geodesic 84.
It depends on where you live.
Oh,
Because
but
there's
that was my
problems.
question.
It doesn't.
It's not like a
Oh,
standard. It's depending on where you are.
yeah.
Interesting.
So basically, let's put it this way: the West, so the United States, Europe, Australia, Canada, probably Japan, they all use this. They've standardized what they use. They use the WGS84 reference ellipsoid. Now, for the record, the geoid, Europe and the United States use a different one, and that's like the deflection of the vertical, which is this curved plumb line thing I'm talking about. And they do this because a plumb line, according to them, does not hang perpendicular to the surface of the Earth. That's deflected by lumpy gravity. So, and that's why the what do you call it? The celestial sphere doesn't line up to the Earth. This is what they say, right? Because what you did do is they compare what their position is based upon the celestial coordinates, and then they do a bunch of measurements on Earth, and then they go, well, my coordinates should be here, but I look up and that's not my celestial coordinate.
But that
So
doesn't make
gravity must be tilted.
Okay, but regardless of gravity, regardless of geography, when I look up at the celestial sphere, it should be like it shouldn't matter what my gravity is, right? Like I
Yeah.
understand that in some spots on Earth it might be more dense and you might be heavier. Some spots are less dense, you might be lighter.
Okay.
But
If you're not understanding, it
wouldn't
does matter
change what
because
happens
when
in the
they
celestial
survey,
sphere.
okay, when you survey an instrument, right, when you have to level it first. It's the first thing you do is level it. But if gravity is tilted, right, doesn't go straight down, then what you're surveying, right, your measurements are different
That makes sense.
because your
we
starting
don't live on a
spatial
perfect
reference is
sphere.
different.
And that's the status quo argument. We don't live on a perfect sphere. We live on a globular but not spherical Earth. And, some spots it bulges and some spots it doesn't.
Is that what you have to tell yourself?
Well, I guess like what you're describing to me doesn't sound like too off of the status quo explanation.
I know what their story is, but these are all fudge factors because they've been trying to do this for a very long time. Okay, and they noticed as early as the 1400s that their land measurement distances, and they use, say, the radius of the Earth, and then use the Haberstein formula to calculate a distance based upon the angular change in the position of the stars, that these two things don't match up. So they created a reference ellipsoid and created an imaginary Earth where they do match up. The reference ellipsoid is just a mathematical surface. It doesn't exist. But all their measurements are projected onto it. Because the sky doesn't match the ground in the way people think it does. But the whole point of this is the way you guys think stuff works and the way it actually works are way different. And you guys are like mad at us for looking. Oh, just shut the fuck up, flat earthers. Don't look at what they're doing.
To be fair to the argument, though, when we're talking about like stuff that we use on a daily basis, whether it's Google Maps or GPS or the numerous other things, these are all based off of a globe Earth, and the whole point of being a flat earther is to have truth and to be more accurate.
But you're repeating the same wrong argument that I just fucking debunked. It doesn't use a globe Earth. In your mind, it does, but in the mathematics, it does not. So, look, bro. Let's say we have a fucking bunch of equations. The equation for a fucking triangle on a piece of paper. And you go, and then someone says, this equation is a freaking sphere, and then they draw a sphere next to it. You're like, well, I'm looking at the sphere. We're using a sphere. No, the equations don't use a sphere. So I'm trying to tell you, dude.
Okay, well, in the Mercator projection, it's using a cylinder. Is that what your argument is?
Yes, and it's
But
projecting
that doesn't
a
give
coordinate
credence
system.
to. It doesn't give credence to the flat Earth, because we use Google Maps on a day-to-day basis, and it gets us from A to B in an accurate manner.
So what?
If it were to use a flat Earth map, it would get us there quicker, faster, more efficiently. Am
Oh
I
my
wrong?
God, dude. You just keep saying stupid shit.
I asked, am I wrong? Tell me how I'm wrong.
How are you right?
Okay, let's go point
How
by
do you
point.
figure? How do you know? How do you figure that
okay,
your
don't.
claim is
Okay,
right,
let's
dude?
not
Tell
go
us the
point by
logical progression of how you walk through that.
I walked through this by virtue of saying the map that we use to get from point A to point B is based off of projection. What is a projection? It's a way of us humans projecting spherical objects onto a
no.
flat plane.
No. No. It's
Or
not
should I
that kind
say unflat objects onto a flat plane?
Look, you know, I mean, I almost don't know what to say after that, because you don't understand the very basic shit that's going on. And I'm not trying to be insulting. This can be complicated. But they're taking points within a coordinate system and transforming them into another coordinate system. It's almost like a game. In one coordinate system, there's certain rules, right? Mathematical rules, axioms, things that are true. Okay.
Sure.
And then when you do the coordinate transformation, you take points and you put them into the other coordinate system using a set of rules, right? That coordinate, so that when it gets in there, it obeys the rules of that coordinate system. Okay. It's not doing it doesn't make the coordinate system real. You're just mapping something to the coordinate system and then transforming it into another. I don't know what you think they're doing.
The same? Are the end results the same? Like,
It
there's
depends
no
on what you're
harm in
doing.
using these projections?
Yeah.
Mercator projection, these translations that are happening?
Yeah, it doesn't. Look, how you think this shit works, bro, I don't understand.
Just answer my question.
There's nothing. Who said there's anything wrong with it?
Okay, that's a great thing to
Dude,
talk about. So
dude,
if
if you want to
nothing
use a
wrong with
CNI
this
dog to
coordinate
find your way around, who cares?
transformations, just listen to me. If there's nothing wrong, if I don't want to put words in your mouth, but if there's nothing wrong with using this coordinate transformation system, when we talk about living on a flat plane but now projecting it to a cylindrical object known as the Mercator projection, why go through all this complicated math if the end result's the same?
Go ask them.
Okay, so you're positing that there is no real purpose to doing this complicated math using these projections. If we just uncoupled this coordinate transformation, then we could
we're
have
not the ones
a
using the
real
complicated
map
math,
based
dude.
on real Earth.
Like, talk about projection. You're projecting. We're not the ones using
You're not
complicated
making an
math.
argument.
You are. You are. The globe uses complicated math.
No. My original argument was that you guys use Google Maps to get from A to B, or a road trip from across the states. My point is that if you guys use this
hold on, dude.
complicated
Why do we do
extra
that?
math
Hold on. Why do we
system-
do that? Why do we use Google Maps?
Great question, because it sounds like if it were indeed true that we did not need these projections to translate, around Earth onto a flat plane, we would get places faster, more efficiently if we just used a flat
I'm still waiting for you to
map on a
justify
flat
saying
Earth.
that again. You still haven't justified your claim. That claim.
What am I supposed to justify?
Your claim. What did you just claim? That we would get places more efficiently. Look, dude. People have taken Google Maps, right, and zoomed in and taken a camera and stuck it on their dashboard and drove the road and filming the road and the Google Maps at the same time that shows the road. And what he's seeing out his fucking window don't match Google Maps. Google Maps is simply a utility to get you from point A to B. Now, it's probably pretty accurate in the cities because we have known city streets. But once you're on the highways, it isn't that accurate.
But you'd agree it'd be more accurate to use a map that is based off of the Earth that we live in, right? Like, for example, Greenland
That's
wouldn't
not
be
what
as
Google
big.
does, though. Google
Hear me
has a
out.
bunch of Android
Greenland wouldn't
phones
be as
that but
big.
bro, Google has mapped with its Android phones all the roads. You understand that?
Agreed. What's your
Okay.
point?
It has path data. It doesn't need any map. Path data of hundreds, if not hundreds of thousands of cars. Like when you go on Google Maps, say if you go tomorrow morning on a freaking on an urban area in the United States rush hour and zoom in on some city, you'll see it'll have slowdowns and speed ups. It'll give you the traffic speed. How do you think it knows the speed? Because it knows how fast the phones are going.
That's using that data.
Yeah, it's using the
What's your point?
accelerometer in the phone to tell you how fast the phone's going. It has all the path data for all the phones. It could have no display under fucking neath it, right? It can show no land masses, no exits. You'd still have a complete map of the freaking roadways over the entire United States. The map part, man, that's just a toy. I'm sure you can shut it off, right? You know how you can change terrain, satellite, you can football, you can change all of it. Set it to nothing and just have the freaking roadways like a bunch of arteries.
I think there's a disconnect here. If I was doing it like a road trip from California to Florida, while I know that I should go east, depending on the projected map that I'm using, drastically changes the path on that map that I'm going. Correct?
I don't start over. I don't understand that.
If I'm going from west to east across the states,
yeah.
If I'm using the Mercator map, it's a hell of a lot different path. Like if I'm drawing my path from California to Florida, if I draw that on a Mercator map, on a flat Earth map, and insert any other random projected map, those paths would be different, correct?
Yeah,
and some paths I'm going straight east, and some paths I'm going, you get the idea.
Yeah, I understand, and dude, that's irrelevant.
I don't think it's irrelevant because my whole premise is that if we indeed lived on
the path data
Earth,
independent of the math projection.
Okay, interrupt.
Yeah, they know the map. I'm telling you why it's irrelevant before we go further. Okay, they know the path data independent of the map. It's independent information. They don't need a map. They don't need a Mercator map. They don't need a globe. They don't need a flat Earth. They don't need a fucking Lambert conformal. They don't need any projection at all. They have the path data.
Maybe I'm changing subjects, but to be fair, I agree with you on the surface. Like, yeah, you follow the guy ahead of you metaphorically, but like it changes whether I'm sailing or flying. Like I go east on this map if I'm flying, and I go north-south on this map if I'm using a different projected map.
What are those things? You just say these words, north, south, east, west. What are they? What is east and west?
Oh, God. Educate me.
They're circles, dude. Did you know that east and west are circles? North and south are circles in the latitude, longitude coordinate system. But in the Mercator system, it's a straight line because you're going around the cylinder. Do you see? Remember I was saying like they changed the rules that like in that there's a particular rule set. Now the rule set in the latitude and longitude is straight lines don't exist. They can't even be represented. You understand that? In the latitude coordinate system, even if you had a straight line, you could not represent it on the map. Do straight lines not exist? I'm asking, do straight lines not exist anymore? Because you can't represent it on the latitude longitude map because that's what they picked. You have a basic lack of understanding of what is being done. That's what I'm trying to tell you. I don't know if you're trying to fake it till you make it, or Dunning-Kruger, or keep pushing your ignorance. I don't understand what you're trying to do. But if you have a type of coordinate system, and that coordinate system has rules, such as no straight lines, then they can't be represented at all within the coordinate system because it's against the rules of the coordinate system. If you could represent them, you wouldn't be in that coordinate system anymore. Yoder's probably listening. He's probably having a fucking nervous breakdown right now. Not a nervous breakdown, but like pulling his fucking hair out.
I took a leak. Give me a break.
Fine. No, I'm not talking about you. I'm talking about Yoder.
Oh.
No, because Yoder, he knows a lot about maps and coordinate transformations and all that shit too. So he was listening. I know he's flipping out, dude, because you just don't understand basically the geometry, the mathematics behind it. And I'm not trying to sound like it is a very niche thing. Okay.
That's an understatement. It's super niche.
Well, the main book published about geodesy is called Higher Mathematical Theories of Geodesy. Okay. This is about the globe. In that book written by Helmer in the 1800s, it's 2 volumes, and volume 1 is 900 pages, volume 2 is 600 pages, and 95% of it's just equations. I'd say even more than 95. 98% is equations. Okay, if it's straightforward, you got a celestial sphere to globe, then you wouldn't need a reference ellipsoid. You wouldn't need all these band-aids.
When you say you wouldn't need all these band-aids, what are you talking about?
All the band-aids that they have to do, curving the plumb line, a geoid, a reference ellipsoid,
Okay.
fucking fatter at the bottom than the top, right? They actually, now they're saying it's not even a oblate spheroid. It's more like what's called it's like a 3 fucking ellipsoids that are kind of mushed together. But we have people like you that think, oh, they just measure the Earth to be a globe. No, they don't. The globe part, man, that's end user for the masses, man. It's just like that globe that you see on Google Earth, that's just to edify you. Underneath, looking at the code, it isn't using a globe. Look at the code on the GPS, it's not using a globe.
I think this is.
I bet you
Sorry,
think
Tom.
the sunrises and sunsets use a globe to predict them, don't you?
Heck yeah.
If they don't.
But we know what time the sun is going to set. And we know what time the
Yeah,
sun's
from
gonna
a model
rise,
that
right?
doesn't use a globe.
From a flat Earth model.
No, it's an observer-centric model.
Okay, but it doesn't rely on the flat Earth, right?
That isn't the point. The point is it doesn't use a
But I think
globe.
that is the point. I
No, the
guess
point
that's
is it doesn't use a globe. But you
I
think
think
it
that's the
does.
thing.
Why did you think it does?
I think that's the thing that I keep going back to is like when you were talking earlier on, like the reason why I jumped into the conversation was because you were arguing that like, hey, dude, when I'm in my workshop, eye level flat and
I
flat
wasn't
and
arguing
plane,
that, but
whatever. Well, I don't want to misattribute, but I
Gravity
heard that,
was.
and that's why I jumped in. And it was like, okay, but you got to be realistic. Whether we're talking about Google Maps, which is based off of a spherical Earth, whether we're talking about the app I use to track the stars in the sky, it's like I can point with my phone down beneath my feet, and it points at Pluto, and it will predict when Pluto is going to be above my head. And these are all using
not this
globe
again.
Earth models. Two more seconds. 2 more seconds.
How do you know Pluto's
These
under
are-
your feet?
2 more seconds. When I use these apps, and they're all based off of a globe Earth model, and when you tell me that
No, they're not. You're still wrong.
You've failed to show that. I've
Yeah,
asked you before to show
still
the data
wrong.
for
They
that.
also don't use gravity, bro. Like you're just wrong. You've imagined in your head they work a way they don't work.
Well, if they didn't work the way I just described, then why would they show me that Pluto is beneath my feet?
Oh my god!
It's a fucking toy. Why did they make a toy that entertains me? I don't know, dude. Figure it out.
But they've modeled this out so that while
and that
Pluto
model
is
doesn't
beneath
use a
my
globe.
feet today,
Yeah, and that model
that
doesn't use a
same
globe,
day
bro.
on Earth, Pluto is above the head of somebody in China. You get my point?
Yeah, but that model doesn't use a globe, Earth.
But it does.
No,
I
but
guess-
it doesn't. You made that part up in your head.
So when you tell me that like the Mercator projection doesn't use a globe Earth, it uses some cylinder, is that a defeater for the globe Earth?
Look.
Is that kind of what you're talking about here?
No. Dude, are you okay? Look, I'm going to say it again, probably for the 7th time. The way things work versus the way you think they work are two different things. You think they use a globe for all these things in the mathematics. You don't think it's just simply a display, right? Google Earth displays a globe, right? But within the code itself, it represents the Earth as a cylinder in the code, in the math. So when it does calculations, it's doing calculations on a cylinder. And then it's transforming to look like whatever on a globe, right? For your edification. Oh, look on a globe, right? So to make you feel better. Your app is doing the same thing. Your app is just getting the ephemeris from probably like JPL, New Horizons, which is empirical. It's not 100% model, and the model they use, it's observer centric. Okay, you understand that all these astronomy models are observer centric, meaning the origin of coordinates is your fucking eyeball. Do you understand that? Imagine your eye is in the center of everything. And then there's a celestial sphere all around you. And that rotates about your eye. That's the math that's happening.
Is my eye static?
Yes.
So I see, Venus
in the model it is.
cut off.
It's
to my east,
listen. Do you not understand?
rise in my
It's the
west.
origin of coordinates. It's the 000, dude. It's the origin of the coordinate system itself. That's where you are. That's where the whole model is based upon that.
And
They
those
say
things
everything-
relative to an imaginary horizontal infinite plane.
Yeah, exactly. And then they got that. I mean, that's a whole nother freaking can of worms. Right? And then that freaking then they have the whole freaking plane where everything is measured up from your eye, right? In angles, 90 degrees. And your app says, oh, it's under the earth. No. What they calculated was that within the celestial sphere, the celestial sphere rotated, placing it at a negative angle below your horizon. But that's just a calculation, because that horizon is just an imaginary reference, imaginary coordinate plane.
They can verify it.
Oh, God.
So like when Venus sun sets for me, or let's talk about the sun. When the sun sets for me, it rises for somebody else.
Yeah, great.
But, so we can verify this.
And then what?
And then we can map.
You think we
the
deny
reality in
that
which we
that
live.
happens? Do you think we deny that sun sets in one place?
No. I'm trying to follow your guys' argument. I'm not trying to throw in some zingers. I'm trying to understand when I see the sun set in the west and rise in the east, and I know that Japan is west of me, and I can call my buddy in Japan and say, "Oh, it's nighttime," or sorry, it's 5 a.m. for you, or I don't know. You get my point, though, right? Like I can talk to people on opposite sides of the earth, and when it sets for me, it rises for them. We
They're
can
not
map
on
the
the
world that
opposite
we live
side
in.
of the earth, though. Yeah. Other than
Okay, I hear you, but nonetheless, this fact still remains.
Yes, so what?
So it gives credence to the argument that we live on a spherical Earth, because I cannot just confirm this, empirically by calling him on the phone, but I can also predict this. I can tell him.
Yeah, but you're not going to use a globe to predict it.
But I think I am.
No, I know you think that. That's the whole point. You think that, but it's not true. That's the whole point of this conversation. What you think is being used is not being used. There is no globe Earth, period. They're not using a globe Earth for any of the calculations. They're not putting you on the surface of the sphere and calculating from the surface of the sphere. What they're doing is everything is so fucking far away that we can assume that you're a point at the origin of coordinates, and we'll do rotations in the spherical coordinate system. That's what the mathematics is doing. It's not putting you on the surface of the sphere. That is coming after the fact. After they rotate the celestial sphere, they're putting a sphere under you. But we could also put a flat Earth under you. We could put a fucking turtle under you. We could put a freaking hyena under you.
The meat of what I don't quite understand.
That predictions of the sun, sunset time, sunrise, fucking solar noon, none of those things use a globe to predict.
Okay, so
they're not using a globe to predict when they happen. And
I know that would. Sorry, go on.
That's the point. They're not. If you look at the math, they're not using a globe. That is how you've imagined the mathematics to be. That's just imagination, dude.
To be fair, even if I was like a Singalese tribe member, if I gave him my phone and I gave him this app, it's not just what the app creator. This feels like a stupid point, so I'm going to stop it. Okay, I'm willing to admit.
Look.
But hear me out. Let me finish
we've been plotting sunrises and sunsets for fucking thousands of years. We know when they happen. They're cyclical.
When the next solar eclipse is, but no flat
that also does
has
not
predicted
use a
this off of flat Earth.
That also does not use
these
a globe.
do.
Shane did that.
I'm sorry.
I know you think.
When I say I
here
think
we go
these
again.
do. This is where the meat is. This is where I totally disconnect. So when I say I think they do, I can't confirm it, and maybe some Googling I could, but like, what is your guys's coup de grace of evidence where they do not take into account the spherical Earth? To like we agree that they're super accurate. We can measure it. We can tell you when the next.
Well, their accuracy is never
super accurate.
Okay, they're not super accurate. I don't know where you're getting that information. Oh, they are. Give us some data.
I went to Arkansas, and I could tell which town in Arkansas I could see the full lunar, or was it solar eclipse?
So what?
And
wouldn't it be more of a post-diction anyway?
What, dude? You got like a 27-mile margin of fucking error.
God.
So what?
And wouldn't that be a post-diction anyway? It's not a prediction.
Yeah, but that's not the point. I don't want to get past this. The way they predict solar eclipses and lunar eclipses is called the Saros cycle, which is the coincidence of three.
Spell that word.
SAROS.
cycle.
It's been the same way they've been predicted for 2,000 years. You can type in fucking Google NASA Soros. That's how they're predicted. The heliocentric model, if you try to do it, doesn't work. And the best evidence for that was the 2017 Great American Eclipse, where Stellarium, Celestia, they all had to patch their software to get the eclipse to work because it was going the wrong way.
Can you source that claim?
You can go on Stellarium's forums, 2017. I think it was August 13th, 2017.
So
Well, Stellarium's known to be wrong, dude.
But I mean, okay, like I'm willing to totally concede, like, oh yeah, we get stuff wrong all the time and we correct our model, etc., etc. But Stellarium is
They didn't
pretty
use the
damn
globe,
accurate.
bro.
But Stellarium is pretty damn accurate, and the people that work at Stellarium, that code Stellarium, believe in the globe Earth. And I guess I have questions
They
around,
believe in
like,
ghosts and fucking fairies.
it's not
Who cares what they
coded.
believe?
I have hold on. I have questions around this idea that it's not coded that the Earth is round, because of the fact that I can point to Pluto today and it's beneath my feet, but Pluto 6 months from now is above my head, and it's true to form.
It's not
It's like,
beneath
it's
your
truth.
feet.
But in the app and the people that code it, it is.
Yeah,
correct?
because they
And if
drew a
I
little
call
graphic
somebody-
on the app that showed, oh, this is
But
Earth.
come on, if I call somebody on the opposite side of the Earth from me,
Dude, it's
and
like
they
you're a
see
broken
Pluto
record. You're not
overhead-
listening. Tell me what I just said.
Chill
All they're
out,
doing is
Indio.
displaying something that looks like ground. It's a graphic. That's
I
not
think-
really the Earth.
Have you
They
used
didn't
Stellarium?
calculate. They didn't calculate where to put that ground.
They didn't calculate.
You know what?
This guy's gonna get muted.
Yeah, he's gonna get worse than that. Fuck, I don't know where he lives. Okay, so it's very simple. It's very simple. All they're doing is just displaying something. They could display you inside of a bowl, right? So if you use a different type of app, like telescope aiming software, okay, there's one called C2A.
Nina?
C2A is a free telescope aiming software. You can hook your telescope up to it, and it'll fucking aim your telescope, right? They don't display, even though they also think it's a globe Earth, they don't display any ground. They just display a fucking horizon, right? Because in the mathematics itself, there's no fucking ground, dude. That's what I'm trying to tell you. There's no ground.
Because ground is irrelevant to where Pluto is in our celestial sphere.
Oh,
So if I
really?
point my phone
So
down
there's no
and it's
globe in
tracking-
math. Thank you.
But come on,
Finally.
no, I don't think you heard me. Because if I'm pointing at Jupiter in the sky, you know, let's say it's directly above my head, it's my zenith, and I'm on the opposite side of the Earth, I can't see Jupiter because Earth is in the way. But if I point to something beneath my feet, like Pluto, those people on the opposite side of the Earth can see it. And so, despite the fact that they use this artificial horizon to display what is out there in the world,
Right. You don't know
it's
if you're
still
pointing at it or
true
not.
based off of this
Pointing at
ground
the
Earth.
ground, not at Pluto.
Yeah. Okay. So there's a model. In that model, Pluto has a negative angle. You're interpreting that negative angle as being physically on the other side of the Earth, and there's no justification for that.
So is the app.
No, so is the app. That's just the graphic they put on there. They aren't
If I
calculating
pointed it
that.
beneath my feet.
You're
Pluto is certainly.
Dude, do you not understand what just like adding some fucking thing into a video game is? There's not
totally
really a
empathize
wall
with this
there,
idea
dude.
Of just make believe video game stuff.
It
But the
is a
reality
video
is that we
game.
can verify this.
The
If
epitome
Jupiter's
of
above my head,
So that's the. But how are you verifying it? How are you verifying?
using this app and using my friend on the opposite side of the
That's
Earth.
circular,
don't-
isn't it?
Hold on. You don't know he's on the opposite side of the world. That's what you're trying to verify.
Well, that's the model that I live in.
No,
And
it isn't.
If the
That- no,
app
it
is
isn't.
worked off of the model in
No,
which
it
I live
isn't.
in, then
No,
we
it
can verify
isn't,
that
dude.
the model works.
No, it isn't. That's the last time. No, it isn't, dude. There is no globe Earth in the model you're using.
Okay, do we
Show it to
agree
me
that the model
mathematically
that
where
I'm
it is.
using?
Show me where
Do we agree?
3,000. Show me
Hear
in
me out.
Stellarium where 3,059 mile radius where it calculates your position on that frickin' ball to do the calculation of what you see. Show me right now.
I don't know what you're asking. And I
I'm
feel like
asking
we're
you
being
to
different
show
on
me
this.
a globe Earth model where they calculate you from an observer on the surface of a fucking globe Earth seeing something. Pluto is underneath it in the model, but you're on top of the ball.
Right. So
They don't
we
do that.
disagree. We
They don't do
disagree that. We disagree that the apps that I'm using, the maps that I'm using, are not based off of a spherical Earth.
This isn't a disagreement. You're factually wrong.
Okay, what am I factually wrong?
Okay, so dude, your
The
original
claim that it uses a globe Earth, that it's a globe Earth model, that is merely a fucking graphic. That is not how any of the calculation is fucking happening in software. And if it's not using its own calculation, if it's using something like JPL's New Horizon Ephemeris, which is the positions of planets, you can FTP it, you can fucking get an app, you can download it. They are also not using a globe Earth. Okay? They assume that everything is so far apart, they can assume the Earth is a fucking point. There is no globe Earth in any of these models. You just think there is. You fucking took your imagination and extended the fucking model into something it's not because they showed you a fucking bunch of pixels of some model that they stuck in their app. You're doing it with your imagination. It's not within the mathematics.
So hung like TikToks, they were able to predict solar eclipses 4,000 years ago.
Yeah, with Soros
Where
cycle.
only
With the
where
Soros
only
cycle, not a
geocentric
globe.
models existed.
With the Soros cycle, not a globe.
So how are they able to accurately predict?
I'll tell
solar
you,
eclipses?
it's the coincidence of the animist. It's called the animistic, the draconic, and the eclipse year. When those 3 years coincide on the same date, there's an eclipse. They've known this since 2000 BC. The first eclipse ever predicted that's known about was predicted by a flat earther.
Well, no, it's not just predicted by a flat earther. They predicted solar eclipses before there was ever a heliocentric model.
Yeah, I know
Do you think
that.
that we've improved since relying on the Soros cycle?
No, because
I think we
4,000 years ago, they built buildings, giant megalithic stone structures that perfectly matched where solar eclipses and other celestial events occurred. We can't do that in 2026, and we don't do that in 2026.
Okay, I want to stick to what we're talking. I don't want to fucking divert into other shit. The fact of the matter is, all these things that you think use a globe do not. Okay, Soros cycle, time and day, U.S. Naval Observatory, SunCalc, all these apps that you use, you've just assumed that there's some in those models. In the mathematics, there's a globe, but there is no globe. There's only the celestial sphere, and you are a fucking point within
I'm
the.
honestly
You're a point
trying
at the
to
center.
understand you. When I use the Stellarium app, which I have on my phone, and it tells me like today,
Doesn't tell you anything.
Be fair to me. Let me finish my question. When it tells me I'm 93,100,000 miles today, and now tomorrow I'm 93,038,100 miles tomorrow, or 12 hours from now, it's taking into account the Earth's circumference. That would be an argument, which I don't even know if it does. Okay, but hear me out. You're telling me like in these code of these apps and the models that I use, they're not even taking into account that we live on a round Earth or a spherical Earth. And like if the Stellarium model showed me as 38,000 miles further away from the sun today versus 12 hours from now, would we agree that it's using a round Earth model?
What are you talking about? 38,000
I'm
miles.
saying
Like the difference in your distance would be 8,000 miles because it would be the diameter of the Earth, not the circumference.
Okay, fair, but you get my point was like I'm trying to understand the burden of proof needed if like some of these apps were taking into account the globular structure of the Earth versus the flat plane
Look,
of the Earth.
I told you
then
what
it
was
would
needed.
then it would add to my argument, right?
Some of you people, dude, are just pieces of shit, dude. Like seriously. Look, I'll tell you exactly what's needed. You need within your model to have a sphere of 3,959 mile radius, whatever size you think the Earth is. Put you on top of it, and then calculate all the angles to all the stars from that position. Not the center of the Earth, but from the top of the Earth. But they don't do that. There's no ball inside the mathematics. You guys just imagine it to be there.
And if I were trying to take an angle measurement from the surface of the Earth versus the center of the Earth, that angle measurement would be different. We'd get more accuracy if I were measuring from my true place in the universe versus this fake celestial sphere that I'm measuring from the center of.
Why do you think the celestial sphere is fake?
Sorry, I meant like the Earth sphere. Like if I'm understanding you right, it's like there's a distinction to be made about measuring from the surface of the Earth versus the center of this, globe Earth in which we measure from.
Yeah, they don't even consider that there's a globe Earth at all. Okay, it's not a consideration. Do you understand that they're just measuring angles, right? So the angle is the separation of two lines. That's all it is. Okay. So where are you going to measure the separation from two lines? 3,959 miles from the center of coordinates or at the center of coordinates? It's just a hell of a lot easier to just measure them from the center because all you're going to do to measure the angles is move them to another place in the Cartesian plane and measure angles from there. Why even bother? Just do it from the center. But the point is that there's no globe Earth in the mathematics. That's the whole point. You guys just say it is. The model, you're trying to reify a model, but that model isn't even a globe Earth in the first place. So I'll walk you through this really simple. Hey, dude, the Earth's a globe. How do you know it's a globe? Oh, we can predict sunrises and sunsets. We have a model that does that. Okay, well, problem one, you're reifying the model. There's all sorts of models that make predictions of things that exist, and they work, but there's no ultimate reality there. Okay, but you guys are going a step further because this model doesn't even have a globe in it to reify.
Where would the globe be in the model? Like I'm thinking about Stellarium. Like where in the code would it tell you that we're accounting for a round Earth?
Well, they would have the radius of the Earth. They would have 3,959 miles. It would calculate your position on that, and then it would calculate angles from a tangent plane on that surface. Because you can't do it from the surface of the globe, because you can't get an angle off a curved surface. So what they would do is they would take the origin of coordinates, move it to some other place. Depending on where they say your coordinate is, they would rotate a freaking tangent plane and then do the calculations off a plane. This actually is not even. I don't think that this is like complicated mathematics.
What is this?
None of this even matters. You're doing a reification fallacy, even if you had a model with a globe in it that made accurate predictions. That doesn't make the Earth a globe.
Well, if places on Earth can't be reconciled with a flat plane and they can only be reconciled with a globe, then that's geometrically proving that it can't be a flat plane. It must be a globe.
Okay, solar eclipses.
We're talking about two
predicted
different
within
things. Hold on.
thousands of years.
Hold on a second. You already said that, dude. Hold on. Now we're talking about phenomenon. Okay, we're not talking about the dude that just talked. There's no geodetic measurements that can't be reconciled on a flat Earth. They don't measure a globe; they measure a flat Earth.
Triangles exceeding 180. Yeah.
Oh yeah. How would you do that?
Theodolite.
Oh, a theodolite. So theodolites have curved lines of sight?
Well, no, we can take angles.
Yeah, in angles between three points, right? A, B, C.
Which should be 180, but if it's over, then it's not a flat surface.
Okay. How would it be over 180 points A, B, C? Theodolites from theodolite 1 to theodolite 2, theodolite 2 to theodolite 3, theodolite 3 back to theodolite 1.
If the internal angles.
Yeah. So how would that be? How would those lines of sight be greater than 180 degrees? Because that's a planar fucking triangle, dude.
Exactly. If the internal angles add up to more than 180, then it is not.
They wouldn't be more than 180.
Well, if they did, it wouldn't be a flat plane.
Yeah, but no one's ever actually measured that.
They do. This is why
I just asked you, how would they do that? You said theodolite. I just gave you an example of 3 theodolites to measure a triangle, and it doesn't matter how big that triangle is. It's always going to be a planar triangle because your lines of sight are not curving.
Again, if
you don't know anything about this, you're just parroting some fucking idiot right now. No, you're just parroting an idiot, and which makes you a bigger fool. Look, think about it for a second. When you're on a theodolite, you're above the surface of the sphere. You're not on it. So if you have 3 points, like toothpicks sticking out of an orange, and if you tie a string between the tops of those toothpicks, that's going to be a planar triangle. That is not going to be a triangle greater than 180 degrees. But if you want to keep parroting stupidity, go ahead.
If it was greater than 120 degrees, it wouldn't be flat surface, right?
How could it be greater than 180 degrees?
If the surface was curved. So if it was greater than 180
but they're not
degrees.
But dude, they're not measuring the surface. They're not measuring the surface. They're
3 points on the
Are they on the surface or off the surface? They're off the surface, right? The theodolite isn't on the ground, right?
Stop saying the surface.
3 points
the surface.
On Earth.
Not on the surface. The points are on the surface, but the line of sight isn't.
If it's more than 180 degrees.
He's like he's a broken record.
If it's more than 180 degrees on a flat surface at the same elevation.
Look at that.
It's not on the surface, bro. How many times do we have to tell you?
Our line of sight's curved. Lines of sight. Did he bounce?
I hope so.
No, he's still here. Why don't you look in the side chat? Stop parroting fucking morons, dude.
Yeah, that triangle you see on that ball.
Yeah?
That's exactly that's the point. The angles add up to more than 180 degrees.
No, they do not, you fucking crap.
Look at the triangle. Look at the triangle on the ball.
Dude, I took this picture. I made this. This is mine.
No, not that one. No. Oh yeah, sure. The orange. Yeah. Measure the angles on that orange.
Yeah. It's 180 degrees.
Oh no, yeah, because you don't have a line of sight between them. You're curving them around in
that's
two different ways. That's not a triangle. You're not making straight lines. So, it's not even straight. It's not even straight over the curved surface. You're curving them around.
Talking about
listen to this shit. You can't
have 3 straight lines. You can't have 3 straight lines, meeting at vertices and equaling more than 180 degrees. You idiot!
No, but if you have if you have a line of sight that does not change left or right, what you're doing here with this orange is they're literally
180 degrees triangle.
no.
Yeah.
Yeah. But again, that's not line of sight.
Yeah.
That's not line
Lines
of
of
sight.
sight are curved.
What the?
Over a flat surface, yes. Over a curved surface, it would curve. It would go over the curve, but it would
The lines
going
of
around
sight.
the curve also would be not a triangle.
Lines of sight are curved now.
This is not like
He's already decided it's a globe. He's already decided his line of sight is curved.
Theodolite,
Indio.
that's not how a theodolite works. Like that orange, like you don't. It doesn't
I thought this
curve
was supposed
sideways.
to tell you about the Earth's
It doesn't
surface.
curve sideways.
You've already decided. You've already decided the Earth's surface is curving.
It doesn't curve sideways.
What are you talking about, bro?
Like if you look forward, your field of view is not going to bend left.
It would have to curve. That's your problem. We know that. We know that. That would be your problem. Because
then why are you painting this picture of this orange?
Because this is what you fucking think has to be happening. Each toothpick is a theodolite. The string is a line of sight.
Yeah, clearly it's not, because it's curving in two different ways. Each way, it's
which way is the string curving?
Between
the lines aren't curving at all.
It's between each point. You have both. It curves over the orange, but then it curves in a circular pattern.
Oh my god, dude!
Like I'm looking at it. It's and if you go above to the image with the white image with the sphere and the triangle cut in it and then overlaid, that is what the one, like on the ball, those angles internally. If those don't add up to 180,
we understand this argument.
I don't think you do understand that.
Oh, dude.
Yo, I don't want to sound like a provocative discussion.
Then go on mute. So, yeah, we do understand this argument very well. So this greater than 180 degree triangle is created by calculation. It's called reduction of the horizontal direction. It's page 47 of the Great North American Trigonometric Survey, whatever the fuck they call it. It's page 47. Yeah, we do know exactly what you're talking about. We know it's measured, which is the blue triangle above the sphere. But then they called reduction of the horizontal direction. They drop this triangle mathematically and project it onto a reference ellipsoid. And when they do this, almost like casting a shadow, it then becomes a greater than 180 degree triangle. But they're not measuring a greater than 180 degree triangle. They're creating one by calculation.
If they weren't measuring more than 180 degrees,
they can't.
If they weren't measuring more than 180 degrees, then they wouldn't have to correct for more than 180 degrees.
They aren't.
Really, there's no corrections for over 180 degrees.
No.
So,
well, brother,
if you look,
it's not even possible.
No one uses spherical excess corrections.
No.
That's not a thing.
It's created by calculation.
No, but it would make them false if you calculated it based on a sphere. It'd be false.
It is false.
There would be no spherical excess corrections.
There is no spherical excess
because
there's no sphere. What aren't you understanding?
The concept of spherical excess would not exist. Like there would not be those corrections.
The concept?
Never over. Spherical excess corrections. Spherical excess.
What is spherical excess?
It is when you get more than 180 degrees.
That's not what it is.
The difference between the sum of the angles and 180 degrees.
Consequence of spherical. The greater than 180 degrees is a consequence of spherical excess, but that's not what spherical excess is. What is spherical excess?
It is the excess of 180 degrees caused by the fact that you are having a triangle on a sphere.
No, it's the excess of surface area that would have to exist if you had a curving triangle like that. Right? So it wouldn't be flat. So you'd measure the distances along these sides, and they'd be longer than a regular triangle. That's the excess. The bulge that's inside the triangle, the bulge of curving Earth. That's the excess.
So the
not the angle excess.
Oh my god. Internal angles would make up more than 180.
Dude, you're like stuck on stupid. You
Right?
just keep repeating yourself like you're like,
You're
dude, this earth is
you're
broken.
vacillating between denial and acceptance.
No one is doing anything
Spherical
like
axis when
that.
it's
You
more than
don't understand
180.
what you're talking about, even
It's
remotely.
more than 180, right?
No, it's not.
Okay, if there's spherical axis and you have a triangle on a sphere,
Yeah,
that's
the
going to be
look,
the
depends
spherical
on the
axis
size
is
of the
what?
triangle. Okay.
What is
Depends
the
on the
spherical
size.
axis?
Spherical excess is the excess surface area inside that triangle compared to a plane. That's what spherical excess is.
It is literally refers to, I Googled it, the amount by which the sum of the angles of the spherical triangle exceeds pi radians, aka 180 degrees.
I Googled it. Well,
Yes.
I took differential geometry, and spherical excess is the excess surface area that's inside of the
Literally,
triangle.
the Merriam-Webster definition defines the amount as the sum of the three angles. Like, that's more than 180 degrees.
Yeah,
The
that's
amount by
not
which the
correct.
sum of the three angles of a spherical triangle exceeds two right angles.
Yeah.
Which is 180 degrees.
That's cool, dude, but that's not
That's
what
the-
spherical excess is.
That's literally the definition.
No, that's what you're reading.
That's the Merriam-Webster
Well, that's not
definition
what
of
I
spherical
learned in
excess.
math class. Okay.
Well,
What we learned in
I don't
math
think-
class
well, you're
is
denying what you
spherical
learned in math
excess
class.
is the excess of surface area compared to a flat plane that a sphere would have if you projected a triangle on top of it, just like this.
No. Find me the definition that says that. You can use Wikipedia, Merriam-Webster, Wolfram, no matter what source, they're going to tell you the definition. So I think you learned math wrong.
I'm going to have to call my university.
Well, they definitely weren't teaching flat Earth.
So what?
If you let me post, I can post this, but this is the definitions.
So while I'm looking for this, so which did they measure? Did they measure the blue triangle or the red triangle? In what Dre's posted. Says the notate. So this is from Wolfram Math World. Difference between the sum of the angles ABC of a spherical triangle. The notation delta is sometimes used for spherical excess instead of E, which is frequently used to denote the surface area of a spherical triangle. The notation E is used Geller, 1989, page 263. The value of the excess of the solid angle is subtended by the spherical triangle, as proved by Harrod in 1603. The equation for spherical excess in terms of side lengths ABC is known as Lefebvre's theorem. So where you go? You fucking in your DMs, dude? So which one do they measure? The blue triangle or the fucking red triangle?
You measure the angles internally.
In the graphic that's posted, which one would be the measured quantity? The blue triangle or the red triangle?
The red triangle.
So they're measuring the red triangle with theodolites. Can you tell me how they
measure
do
the
that?
internal angles.
Can you tell me how they do that with theodolites? How they measure that red part? Do they set the theodolite under the surface of the Earth, or do they make the lens exactly fucking parallel to the surface?
What?
The theodolite, dude. You said they measure the red part. How do they do that with a theodolite? I want the technique.
How theodolites work?
I know how they work. I want you to tell me the technique of using one to get this red triangle.
The technique.
The technique, the methodology used to get that they measured this red triangle. I want to know the methodology.
Well, if you set a baseline point,
Okay.
and you set up a theodolite.
Okay, where's that
you
going to
do-
be on this ball here? Where's that going to be?
You could do it anywhere.
Will
You
it
could
be
do it
somewhere
100
on this
you
vertical line that's not on this surface, or is it going to be on the surface?
What? You
So
can put it
there's
up-
these
you can
vertical
put it
lines,
at-
green. There's 3 vertical lines: green, blue, red. Okay, where's it going to be on these vertical lines? The theodolite, the lens.
What?
It's gonna be. What do you mean what?
I think you're asking something. I think you're asking. You're trying to work through your own confusion about this.
No. I'm not confused.
If
You're
you put a
dissembling now.
theodolite,
We're gonna use
as a
3
cir-
theodolites, dude, to make our
if you have
triangle.
a theodolite
Uh-huh.
and you set it up,
Uh-huh.
let's say at some altitude, I don't know,
Uh-huh.
X, and then you set up theodolite.
So not on the surface of the Earth.
Well, the theodolite is going to be. You understand that theodolite's not like you think you're going to build it underground and like
That's
look
what
at
I
it
asked
like
you, because that's the
no,
only way to get this red triangle.
no. If you have 3 points of the same
Uh-huh.
altitude,
Uh-huh.
and you look at it, you use the theodolite and you look at the angles between those 2 other points,
Uh-huh.
and then you take those angles from each point. Like right now, wherever you are, you can probably take the angle between a
No, that's
building and
gonna
the
be this.
distance,
Yeah, I
and
understand.
then
That's
you
gonna be
take those
this
3
blue
angles,
triangle, though.
and then you
What
take
you're
those 3 angles.
describing is this blue
No,
triangle right here.
you take the 3 angles and you add them up, and if it's more than 180 degrees, that is not a flat surface.
Well, it can't be, because you're making this blue triangle right here.
No.
Well, you said it's not under the Earth. It's
What do you
up
mean
in the
under the
air.
Earth? What do you mean
So
under
up
the
in
Earth? It
the
doesn't
air
mean
is this
under the
blue
Earth.
triangle. Up in the air is this blue triangle.
No, it's
You're
not.
being as dishonest as a
No,
motherfucker. You know it.
it's not.
No, you're a
It's
dishonest
not,
fuck,
because
bro.
if
You're
you have
dishonest. I hope people in the
the
freaking
theodolite, it's like
YouTube
saying
stream
if you
can
take
see
a
you.
photo, your phone camera is not literally in the ground.
Okay.
Like, what
That
are
is
you
our
talking
point.
about?
You're saying the red line is what they're measuring. However, each point of that red line triangle is not visible to the other because you believe there's an Earth curve in the way. So no one is
there's
measuring
still
that.
visibility.
No
Still
one
get
is
visibility
measuring
over-
that line.
You can still get visibility.
Yeah, when you have visibility, you have a planar triangle between those points.
No, if you have a point
Yes,
that
because
is
it's above the surface, and so it's not curving along the surface, creating a spherical triangle.
if the
And
angle,
so that's where the spherical axis comes from.
Okay,
no, if
let's
the
just
angle,
hear this,
if the
Donald.
angles
Donald,
internally,
straight.
if the angles internally add
Yeah,
up to
we
more
know,
than
dude. You
180
don't have to
degrees,
repeat yourself for the 9th
then
time.
it is not a flat plane, right?
Yeah, that's great, but that's not what they're measuring.
Yeah, but that is what is measured. That's why
Okay,
people
and
have to
that's
correct
what's in
spherical
contention. That's what we're
axis.
gonna. If you have to look, if you have 3 points connected by Donald, if you have 3 points connected by 3 straight lines, is that a planar triangle?
They're not necessarily straight lines. That's the point.
No, if they are connected by 3 straight lines, is it a planar triangle?
3 straight lines, completely straight, no curve, then it should be a 180-degree planar triangle.
Okay, so are the lines of sight between the theodolites, are they straight lines?
Some of them are.
What do you mean some of them? Which ones aren't?
There's straight line of sight. So if you have a
Yeah,
line
that's
of
right. Straight lines of sight. That's right.
well,
straight
line
3
of, no,
straight
no,
lines
no,
of
no, no,
sight
line of, no,
at
but line
3
of, no,
points
listen,
creates a
no,
planar triangle, Donald.
hold on. Line of sight corrected with refraction.
Corrected with
No, like if
so
you
not
see
measured.
something, if you see something,
So not measured.
Well, if you see something,
so
and you
not
measure
measured.
the angle, well, you measure the angle internally.
So not measured.
Yeah, you measure the angle. It should be 180, right?
So
if it's
not
more
measured.
than 180, then it's clearly not a flat surface.
So not measured.
Yes, if you measure more than 180, measure more than 180. If it's measured as more than 180, it is measuring as not flat.
But you
if
can't.
It's measuring as more than 180, then you're measuring not flat.
You can't do it with a theodolite. You could only do it with a chain.
This is done. This is why they have spherical axis.
No, it's not done.
Yes, it is.
You don't know what you're fucking talking about.
That is literally what spherical axis is. It is when it's more than 180.
Yeah, but it's never been measured, dude.
That is why they have corrections for it.
Donald, you can chant all you want. It's never been measured.
It had. That's why they have corrections for it.
Then tell us how they do it.
I just did.
No,
you're having trouble with this.
You said that they measured straight lines of sight and then corrected it. That's not a measurement.
They measure the angle between different points.
Okay. That angle, because they have 3 straight lines of sight, has to be 180 degrees.
Again, a straight line of sight does not imply a straight, flat surface.
No one said it did. That's a straw man. That's a straw man, and you're trying to deflect. No one said it implied a straight, flat surface, Donald. What was said was, if you have 3 lines of sight and 3 points, it's a planar triangle and not a spherical triangle.
If you have,
yeah, dude. If
you're measuring, if you're correcting for spherical excess and it's more than 180
then it's not a
degrees,
measurement.
If it's measuring, if you're
then
measuring
it's not a
angles,
measurement, Donald.
If you're measuring angles internally of more than 180 degrees, then that is not a flat surface.
We heard that. You said that like 50 times,
You're
but
not
nobody's
denying that
actually
they're even
done that,
measuring.
Donald. But Donald, nobody's actually done that, and you've admitted it.
No, that is done all the time. That's why there's spherical excess corrections.
Yeah, no, there is not.
Yes. Why do spherical excess corrections exist?
They don't. Show us one.
They do. You
show us
literally
one.
saw one. I think.
Donald, show us one.
equation
Post it in the
right
chat.
there.
Show us one in the chat right now. A spherical excess correction. Show us.
I can't post in the chat, but if you let me post, I will.
DM it. I'll
DM
post
it.
in the chat.
Just let me post in the chat.
DM your spherical excess correction. DM it.
Oh my god. Just post in the chat.
You're gonna go on mute until you give it to me if you don't fucking DM it.
Oh my god. DM you? Really?
A reflection correction?
He's gonna show us the spherical excess correction.
Okay. I want to know where his spherical triangle is.
It's in the correction.
No, but I mean, like, when he thinks that they're actually doing this out in the field, where is it?
I know where it is.
It's not on the surface. It's in the air. It's above the surface. So are you measuring spherical excess of the air? Because it's not on the surface.
If the altitude is the same, then it is.
Hi guys.
No, it doesn't matter if the altitude's the same or not. No, it doesn't.
Well, Donald, I know you're not going to understand.
Then it's not a flat plane.
Well, I don't understand.
Shut
Because
up,
it was done
nerds.
in the air. It's
Shut
not a
up,
flat
nerd.
plane. Are you a
Shut up,
retard?
nerd.
So, Donald, I know you're not going to understand this, but I'm going to post it anyway. So this is a transcontinental triangulation. How to do a baseline. Reduction of the horizontal directions to sea level. Do you have any idea what this means? What this is? It's page 47. This is the very first instruction on how they did the surveying, their methodology. This is the very first thing they do. After taking their angle measurements, that you admitted they do. What is this? The resulting directions at a station as given in the abstract still need a small correction to reduce them to what would have been the object observed upon then at the sea level. Why do they have to reduce it to sea level? Because they'd have a planar triangle. So they have to project, just like I said, that triangle, just like it's in the graphic, onto a sphere. In this case, they're projecting it onto the Clark ellipsoid. They've never measured spherical triangle in the fucking history of surveying, ever. It's not even possible. You understand? It's not even possible. But you're trying to tell us they measure it.
It is literally. You understand that
You
light
can't tell us
bends,
how they
right?
do it.
Light bends, right?
I just showed you how they do it. No, light does not bend.
So so mirages don't exist. We're actually seeing that. Like those
That's a
are real.
reflection.
Okay, but if light's not bending,
That's a
then-
reflection.
Yeah, but if light is reflecting light. If light
Reflecting
is
light
bending,
isn't bending light, dude.
if we see things that are bent, then they're clearly either light is bending or they are bending.
No, there's things called reflections, dude.
That would be looking at yourself. If what you were looking, if
Oh
your
my
line of
God.
sight, if the thing you're looking at is literally
What's an inferior
bending,
mirage?
oh my god! If what you're looking at is bending, then
What's a
it's
superior
either
mirage?
bending, either light's bending or it's bending.
What's a superior mirage? What does that look like? It's a double image.
It's not going to save you. It's not going to save
It's
you.
a double image. It's a reflection.
Cool. And when
What's
we
an
see things,
inferior mirage? It's a
and when we
double
see
image.
things,
It's
when you
also
see,
a
if you
reflection.
don't see a double image and you see something bending, then it is clearly not bending, right?
What are you talking about?
If you see something bending or rising or sinking, then either light is bending or the thing is bending or moving. Clearly, it's not the latter.
Doesn't have to be bending.
That is literally what it's either the first or it's the second.
No.
Either the thing is sinking, rising, or bending itself.
You know
or
that
light
light is
bending.
not a ray, right? You know that,
Light
right?
goes through air. Light is
You know that light is not actually a ray.
They are photons that go through air that bend.
Oh,
They
photons.
go up
Jesus
past.
fucking
Yes.
Christ.
Either you think that their windmills and oil rigs are actually sinking and bending and rising, or light is bending.
No, I think it's more complicated than that. Okay. So you're trying to get away from the fact that this says right here that they do not measure greater than spherical. They don't measure spherical triangles, that they create them by doing this very first step, reduction of the horizontal directions to sea level. This is the very first step in surveying. After the measurement, before they write it down in their little logbook, they do this mathematical operation and then they write it down. No one has ever measured the spherical fucking triangle. So you're listening to fucking morons. And even if light was curving, they didn't measure that curve. And actually would have to fucking corkscrew because the tilt is in two directions. It's tilted back and sideways. So not only does some object in the distance need to be tilted backwards, it needs to be rotated, which no one's ever seen. Because if you read this, what's it say? The reduction is due to the circumstances that the verticals at the stations are not in the same vertical plane. The correction changes the vertical plane, moves that point down to a reference ellipsoid, and then calculates between those 3 points on this new triangle a spherical triangle. None of this shit's measured. But you guys try to bullshit people and convince them the Earth is a globe based upon erroneous information. Your erroneous interpretation of what's going on.
The line of sight would have to be veering off to the left and curving over the ball.
Yeah, it would corkscrew.
Yo, 6-7.
Done. I'm gonna mute you if you keep it up. Second time he's done that. Yoder must be having a fucking aneurysm. Yoder, I'm sorry I gave you an aneurysm tonight.
I don't get how he doesn't get the toothpick thing in the orange. Like, I don't. It's just so. That's just so simple to understand, man.
He gets it.
I can post a way you can look at this, or an observation.
I still don't have those spherical excess corrections.
If you had, this would be a spherical excess observation.
Yeah, how? You only have to tell us the method.
You can look. You can use the stars.
You can use the stars to measure the Earth.
Spherical. You can to measure triangles, like relative positions.
Oh yeah?
Yeah.
Don't you have to measure the baselines?
So it's point of reference. I mean, you can use trigonometry. If you have,
what does that mean?
What does trigonometry mean?
No, what is you just use trigonometry? That's not an answer, dude.
If you know where points are, you know how far away from each other you are.
Oh, that's what I said. So The baseline. That's what I'm talking about.
Yeah,
The
but if you know
baseline.
how far you are from each other,
Okay.
you can all
How would
see
you know
something.
that?
How do you know how far you are from someone?
Yeah.
How do you measure distance?
With a tape measure.
Is that the only way you know how to measure distance?
It's the only accurate way.
So you're not measuring curving of the Earth unless you're using a tape measure, right?
No. Yeah.
There you go.
Talking
Yeah.
about.
You
Yeah.
can't be dishonest. You
We
can't be
did.
dishonest.
We did
No,
use
so
a tape
you-
measure.
so
But we
no, hold on.
did use a tape
You don't
measure.
use tape measures over water. No, that's bullshit. You
No,
use
but you measure the
cameras.
height of the dude.
No,
Idiot.
no, no. Oh, right. Yeah, you measure the height. How? You just said you can't
With a
without
tape measure.
Yeah, but the distance from you to the observation, you're not sticking a tape measure over water, are you?
No.
Exactly.
But this is an internal critique.
No, it's not. That's literally shitting on your own any ability to measure distance.
No.
You're
Like
just
the
saying you
FE
can't measure
core.
distance
The
now
FE
because
core is
if
an
you knew
internal
how far
critique.
you are,
Dude,
it
you can
would
blab all you want.
All you need to know
FE
is how far
core.
you are from each other.
FE core is an internal critique. And in their document, it even says this is a test of the WGS 84 reference ellipsoid. It's an internal critique.
No,
So they used the globe distances.
I'm telling you how you can get angles and measure great triangles using the stars. And if you know how far you are from each other, yeah, we can figure out how far you are from each other. Measuring distance.
How?
You don't know how to measure distance?
I do. Why you keep asking me that?
Because you're acting like that's absurd. If
So
you can
how
measure distance,
how do you propose to do it?
Then you take. How do you breathe? Like
How
do
do
I
you
have to
propose
explain
to
that
do it?
too? So if you're,
This is
if
so
you know
funny.
the
You guys always do the same thing. Once I
if you
say
are
ask you guys
known, if you are
how
at
you
places,
measured the distance, I know where you got the distance from. This is a game, okay?
No, if you know
You
the
assumed that
distance
the Earth
from-
was
if
a
you
globe,
know
and you
the
did the
distance from
Haberstein
you-
formula on
you
the
know
globe you
the-
already presupposed existed. Okay,
If
that's
you
where
know-
you got your fucking distance from.
if you know the distance from you to
Yeah,
someone else,
by doing what? Calculating the Earth to be a globe?
no, if you know the distance from you to someone else, and you know the distance from you to another person, then if you can all see the same thing, if you're all in like a room and you can all see the same object, you can measure your angles between each other. It's not that complicated.
Yeah, but that doesn't work for celestial objects.
Yes, it does.
No, it doesn't.
Why wouldn't that work?
Because the light's parallel, remember?
What?
What? Did you forget?
It's parallel to everyone?
Apparently.
So if you're on the South Pole and you're on the North Pole,
Well, this is what we know.
you're going to have the same sky?
Look, you can have the
Same
same
orientation?
sky, but that doesn't mean that, like, if you took your
so
line.
it's-
Well, brother, you're going to ask me a question and you're going to answer it? That's hilarious. Let me answer the question. Okay, tell you exactly what I mean. That means if there's an object in the sky, okay, and you're looking at it and somebody else is looking at it, if you took your lines of sight and extended them, they would not intersect at that object. You understand? And I know that seems counterintuitive, but if you actually take like 3D models such as AutoCAD or Blender or one of those,
So it's not
and
flat,
let me
what?
finish. If you take AutoCAD or Blender, right, and you take the sun azimuth and elevation angles, or the moon, or any other thing, and you stick them and model them on the surface of a globe, and take those lines of sight, those angles, and try to intersect them in 3D space, they don't intersect.
If you're looking at the same object and a line goes
Yeah,
from you
that's
to
what you're
the object-
assuming.
No, hold on.
You're
If a-
assuming you got a line of sight that intersects at the object somewhere in 3D
if
space.
you're looking, if you have a line of sight at it, if you can see it, then you can have a line of sight straight line towards it, right? If you can, if it's right, if you can see it, you can make a straight line towards it. If someone else can see it, they can make a
geometrically,
straight
yes,
line
correct.
towards it. And if you're on a flat plane, you can make a straight line to each other.
That is true terrestrially, but it's not true for celestial objects, dude. What don't you understand?
No, but again,
I
you're
know
saying-
you
you're-
believe
you're
in
asserting it's not true.
uniformitarianism,
No, you're
and that you're
asserting it's
in the
not.
cult of uniformitarianism.
You know,
some
you're
things are
asserting-
different than other things.
You are asserting it's not true, but in order for it not to be
I gave
true,
you an example of it
laws
not being
the
true
laws
and proof that it's
math
not
wo-
true. I didn't just
Since-
assert it, Donald. I didn't just assert it. I proved it. Okay.
No, you didn't.
I'll post the AutoCAD. I'll post the AutoCAD video in the chat right now.
AutoCAD, if you can see something in the
Yeah,
sky.
AutoCAD to 13-digit precision. Yeah.
If you can see something in the sky, you can draw a line from
This
you
is
to that
using the
thing.
sun.
you can draw a line from you to that thing. Okay? Because you have a
Okay.
line of sight, you can see it. If someone else can see it,
Yeah, I know.
then
That's what
you can draw a
That's
line
what
from
you're
them to it, and
thinking.
then you
That's
draw
what
a
you're.
line between
Look,
each other.
bro. I understand what you're saying. You're spurging because this
You're
like you,
spurging.
it goes against everything that could possibly be true. What you're saying is true for you personally and terrestrially. It's not true for celestial objects.
It's not about terrestrial or celestial. It's basic math. Like if there's a
basic
line,
math.
the laws.
Where does this basic math come from? Does it have to have some
Euclid?
correlation? Does it have to have some correlation to reality?
It is correlated with reality, like straight
Okay,
lines.
so I'm
You have
telling
a
you that
line
it's not
between
in this
you.
case.
Wait. So if you have a line between you and the object in the sky, let's say it's a balloon. Like if you have a plane in the sky or a balloon, you can do the same thing. See the thing when someone else sees it. Draw a line from you to the person,
And you
then a
mention
line
again
from
a
the person.
terrestrial
You have
object.
what?
And you keep using terrestrial examples to prove the
You
celestial
own
examples.
There
Is
is
it
definitely
hard to
no. There is
understand that they don't
no.
behave the same way?
An object can be on the ground, in the air. It does not change math. You realize that, right?
Math is not reality, dude.
Okay. Now we're just 2 + 2 = 5. Okay, sure. Like that's where we're at now. Okay. I think you should unmute someone else because that's. I think
Okay,
this is-
do you not? That's logic. That has nothing to do with math because the equal sign
You're
is
just
the law.
denying math
The
now.
law of identity. I said math is not reality.
Yeah, if that's your response to
Oh, you think
mathematical
math is
proof, then
reality? No mathematician thinks that.
if you can prove something mathematically and your response is math isn't reality, then I think the conversation is done.
Okay, you're not proving it mathematically. You're just jumping
That
to
is
the
a mathematical
conclusion that the geometry that you apply to terrestrial observations is applicable to celestial ones. There's no justification for that belief.
Yeah, if it's a flat surface and the object is
You're
above us
just
on a
claiming the
flat
same
plane,
thing over again. You're just ipsy dixit repeating yourself.
mathematically it would be.
Do you have any
correct, right?
evidence? Do you have any evidence that the laws of geometry that we apply to terrestrial objects on Earth equally apply to things in the sky?
Yeah,
Any
they follow normal physics. They follow
no, this is geometry.
Yeah, and with geometry, the laws of physics and math, they work the same.
The laws of physics and math. You're just saying buzzwords, dude.
Yes,
I want the justification.
2 + 2. We are not seeing
But
2
that's
+
what's
2
in
= 5.
question. But
We're not
Donald,
seeing any
that's
changes
what's
to
in
this.
question. The math that's
Laws
proven.
of physics and math are different.
Okay, yeah, it's great. So what?
Yes, and both
are
are
you not
consistent
understanding
in this?
Donald, shut your mouth and listen. I asked for the justification that your terrestrial application of math that works terrestrially. What's your justification for using it for celestial objects, and what's your evidence that it works there too?
Because math doesn't care whether or not you're on Earth or up in the air.
So
it's math.
Okay, so we can apply Newtonian physics to quantum objects, right?
Physics is different from math. If you wanted to use a frame reference,
no, because
the math would be the same.
they have a
The math would be
position.
the-
No, because
the rules of
objects.
math-
No, good try, Donald.
The
But
rules of math
quantum
would
objects
be
have
this-
to have a. They have to have a position. So did they
The
not have a
rules- the
position?
rules of math-
Quantum
the rules-
objects have a position.
The rules of math would be the same.
Oh, so they have a position.
No, the rules of math would be the same.
Yeah, so they have a position, right?
What is a position?
A position. A quantum particle.
What has a position?
Quantum particle.
Quantum particles.
Yeah, like an electron or photon.
They have positions.
Do they have a position?
They have positions that are, or electrons can have indeterminate positions.
So
but
no
the positions
position.
don't reveal themselves until you look at them.
So
But
if I
that
try
is
to
not-
express them mathematically in a Cartesian coordinate, there'd be no
can't-
place there'd be no dot on that Cartesian coordinate where I could say this is where the electron is, right?
Well, you wouldn't be looking at it beforehand. That's the whole
Why
point.
can't you answer a fucking question?
Well, I'm explaining to you that your diversion here is a diversion. It has nothing to do with what I'm talking about.
It's not a
The rules
diversion.
of
I'm giving
math-
you an
the rules of math-
example.
the same
I'm
rules of
giving you an
math.
example of you being wrong.
No, we're talking about a point of reference that we can both see.
A point is a geometric object.
Like even with quantum science, they still use positions of relative positions to make calculations.
No, they don't.
Yes,
You have no idea what you're talking. You have no idea.
No matter how you
look. No, you
try to
have
get
no
around
idea what
this,
you're talking
you
about.
can
Don't do
use
it, dude.
math to triangulate.
Dude,
It's not that. It's not that complicated.
Okay.
It's geometric.
You can use math to triangulate. Are there circumstances where you can't use math to triangulate?
If you're in non-Euclidean space.
No. Are there no?
That is one
that's
circumstance.
not true.
That would be a circumstance where it'd be harder.
Would it? Can you triangulate the sun?
Yes.
Oh, tell me the technique for this.
You know the distance between yourself
Where
and
would you know that?
other people.
Okay, and then
you could look at angles between yourself and when
okay,
the
so you're
sun
going to
goes out of-
measure. So what's the difference in angle between, say, two people 2,000 miles apart?
Well,
What's the difference in their angle of the sun?
If you take the difference between known locations and angles between them, you can coordinate when the sun goes out of sight, how far you are between each other, and using
No,
those
that's not
positions.
measuring. No, that's
Yes,
not using
it's
triangulation.
trigonometry. It's
That's not
trigonometry.
true. No, it
It's
isn't. No, it isn't. No, it
Yes,
isn't.
it is. It's
Then why'd you
literally
use
Pythagorean
time?
theorem. If you
Then why are you
measure the
using time?
angles-
Donald, where's time in trigonometry?
It's not about time.
That's what you mentioned. You
No, I
mentioned time.
didn't. If you
Yeah, you did.
No, I
when
didn't.
the sun goes down,
It's
when the
about-
sun goes
it's
up, when
about
you see the
hold
sun,
on.
that's time.
Oh my God, you're not. It's not
Okay,
good faith.
so
This
we
is not good
know.
faith. You're
Now,
not
you're
acting
full of
good
shit.
faith.
You're just full of shit. I'm just letting you just twist
You can
around.
You use the Pythagorean theorem. You can use triangles to measure distances, like you see
So-
how far something is.
So
It's
if the
not that
angle is so
complicated.
small, that it's immeasurable, what happens? Can you triangulate the sun?
Well, the angle is not too small. You can.
Well,
Like, if the
you
angle
gotta
is there, you
tell
can.
the astronomers this because they say it is.
Well, if the angles are hard, then
Well,
you
why
can
do the
get better
astronomers say
points
you can't
to create bigger
triangulate the
angles.
sun? Why do the astronomers say you can't triangulate the sun by looking at it? Why do they say that?
I don't know why the guy says that.
Why do they
Maybe
say
with
that
your
you
own
can't
eyes,
triangulate
because
the
you need a
distance
lot
to the
of-
moon by
because
looking
you
at it?
need a because you need in what I described, you need several people around the world coordinating different information.
Then
so
why didn't
one
they
guy
do?
looking
Yeah,
at
they could
it,
have did that in
not
three.
going to do much, is it?
Yeah,
Like,
so why
if you
didn't
use basic math,
Copernicus
basic
do
math.
that? Well, why didn't Copernicus do that?
Because okay, if you have basic math and people
Yeah,
set up in different places, they could figure out where things are relative to other people. It's called triangulation.
Yeah,
need to
you're
look
just
this
gonna
up. You
say
need to look-
you're just saying
you need
buzzwords
to
that
look
you
up
don't understand,
triangulation.
brother. Why didn't Copernicus do it then?
Sounds like a question for you.
No, why didn't Copernicus do it? He could have just did trig. How come they had to use the transit of Venus and they couldn't
I
just
don't
look
think
right at the
Copernicus
sun?
was- I don't think the theodolite
Donald, you
was
just don't
around
know
back
what you're
then.
talking about, and
I
I'm
don't think the
just
theodolite was
watching you
around back
twist around and try to bullshit. Okay, it's well
You're
known.
bullshitting. You're
It's written
literally
in the leaflets of
squirming
the
out of the- you're
Astronomical
squirming
Society
out
of
of
the
reality right
Pacific. Okay, in the leaflets of the Astronomical Society of the Pacific, 1943, Harold Weber wrote an article called the Solar Parallax, which is about which you need parallax to do trig
Sounds
to measure the
outdated.
distance of the sun. Okay,
Again,
there is no solar parallax.
Very old. Why don't you use modern stuff?
So the parallax since 1943, it came after that.
No, I'm saying why don't you cite modern technology? It's like
When things are very far away, you can't triangulate the distance, which is
Yes,
why
you
they
can.
say the rays of what. If the angles are the same, you can't triangulate. You basically have two 90-degree angles, dude. Where do they intersect? You need an intersection point.
again, if you know places on Earth, then you can coordinate.
You need to know where they intersect. So if the angles you measure at these places on Earth, let's say one person goes to the North Pole and sees the sun at 90, and another person goes to 45 latitude and sees the sun at 45. Triangulate the distance to the sun. Go for it.
Yeah, you would draw a circle, a triangle between
Yeah,
those.
you draw two lines, right? Those lines are fucking parallel, you dumb fuck.
Yeah, but that's not reality.
Those
is
lines
it?
are parallel.
No, but
That is
that's not-
reality.
That's not reality.
That is reality.
No, it's not.
Yeah, it is. I just cited it. That is the reality. This is what I'm trying to tell you, and this is what you're fucking being a goddamn cultist about. The fact is, when we cannot triangulate by direct observation the distance to any object in the sky, any one, pick one, Mars, Jupiter, Venus, a star, the sun, anything, not a single one. That's why I asked you for your justification.
Yeah, but if the
Think I don't
distance-
know
hold
the
on, but
answers
if
to the
the
questions
distance-
I'm asking you?
But if the distance, hold up. But if you're measuring the distance between you and other people on the ground, or if you know the distance between you and other people on the ground, then you can use the angle measurements of you and triangulate between you and objects that you can both see to cross-rep and coordinate.
But if it's
the
so
angles
far
between
away, that
the
angle, they're
angles
going to be
between the
parallel
people on the
lines,
ground.
dummy.
The
Dummy,
whole
they're going
point
to
is
be
to create
parallel
is to
lines.
triangulate.
Dummy, they're going to be parallel fucking lines if it's so far away. Triangulate means triangle. You cannot make a triangle with two.
So from your perspective, if you were to create great triangles on Earth using, large points, altitude points that everyone's aware of, and if you were to look up at the sky, you're saying that you would see the exact same sky?
What the fuck are you talking about?
Because if not, like if you can see objects like the same thing and you don't have literally the exact same sky, then you can triangulate. You can triangulate angles between each other.
Okay. So why do they say the sun has parallel rays, dude?
Well, if the sun is directly over, then it's going to be parallel. It's very far away.
The rays of the sun are parallel. Why? Because it's very far away?
Well, if the sun is setting, then it's not.
So how do you
above is it?
triangulate
No,
two
but if the sun-
parallel lines,
if
dude?
If the
Donald,
sun,
tell
okay,
me how to triangulate two
if
parallel
the sun
lines.
is
I
on
want to know
your
the
horizon,
technique.
if the sun is on your horizon and
It's
it's
a simple
directly above
trick.
someone, if the sun is on your horizon and it's directly above someone else, then you can triangulate the relative positions between yourselves. If an object is 90 degrees, like on your side, and for someone else it's directly above them, then you are not on the same flat plane.
Dude. Okay. Don't try to change the subject. Okay. Really simple. How do you triangulate?
And then you can look at the distance between yourselves.
I'm going to kick you out of here. You interrupt me one more time. How do you triangulate two parallel lines?
Two parallel lines. Well,
Yeah,
they're
how do
not
you
parallel.
triangulate them? Because you don't have a triangle. How do you do triangulation without a triangle? That's what I want to know.
Well, they wouldn't be exactly parallel, would they? And you
what are
would
you talking
take
about?
measurements. You would take measurements between you, the internal angles between you and the observed thing.
And
then the angles between other people in the observed thing.
Okay, can you show us somebody ever measuring the distance to something using trigonometry? I want data. I want data.
I can't post in the chat, but
you're still missing the other DM too. So I want data that somebody actually did this. Because this would be your justification that, hey, dude, things we observe in the sky are the same on Earth because we can triangulate things in the sky. That's what we're trying to establish. Can you triangulate things in the sky? I already know you can.
Things. You can triangulate things.
Yeah, that's your claim. And it's wrong.
Now you're anti-triangulation. It's like
no. That's a straw man. That's a straw man. You're so desperate. You're so desperate right now. It's well known in astronomy that no object distance can be.
You said that's your stance. I said you can
no, you're just that's not my stance. That's a straw man, and you know it.
Actually, you were denying. Like you were saying, how do you know it's the same math? Like math is not the same when things go up. It's like terrestrial math. It's like, bro, it's math.
It's not dude, who said every quantity? Yeah, I'm getting pretty fucking irritated with your bullshit. Okay? You dishonest little puke. Really simple. In the formula, you need to
Just
put
look at what I
measured.
sent you. Just look at what I sent
You need to put little measured quantities into the variables, right?
Just look at what I sent you.
Yeah, Metabunk. I debated Nick West. He's a fucking idiot. There's no reason even to look at it. It's not going to change the fact that it's a planar triangle.
If you don't want to look at it, that's your problem.
Do you have to put measured quantities into the formulas? So Google Earth is his measurement? Google Earth, are you serious? And this is a hypothetical. No one did this. There's no observation data here. They did this in like Stellarium or something. This is your evidence Google Earth. Oh, I'm posting this in the chat, dude. Dude, you're just embarrassing yourself at this point.
What's incorrect there?
It doesn't represent reality.
Yeah, which one's off? Which number?
Google Earth.
Yeah,
It's not a
obviously
sphere. Google Earth is a cylinder. Google Earth is a cylinder, and he drew it on the fucking sphere.
Okay, are any of the numbers wrong?
Yeah, Earth's not a sphere.
Which one of the numbers is wrong?
They're unsubstantiated, Donald.
So
which one is right, Donald?
Altitudes are
Donald, which one is right?
unsubstantiated?
Donald, I can play this game too. Which one is right?
I don't know what this like. You're
Which one
saying
is
they're
right, Donald?
they're
Which number's
altitudes.
right?
I don't know how you.
Yeah, which number's right, Donald?
Well, I think they're all right.
Why?
Well, I mean, one, you can easily just check altitudes, and two,
Because you
I
can
don't
do so.
assume. I
Now,
don't
listen, what you just
assume-
said. Because you could check it out means it's correct. You're a fucking idiot. You're an idiot. Just go on fucking mute, dude. I can't deal with people as
Occam's
stupid as you.
razor. It's Occam's
Because you
razor.
could check it means it's
No, no,
correct. That's
no.
why you think it's right. Because it could be checked.
If you're asking me why I think
That's what you
something's right,
said, Donald. That's the dumbest
if
shit
you're
I've ever
asking-
heard in
yeah,
my
if you're
life,
asking
dude.
me why I think something's right, and I say, well, you could just easily just check it. Like
That's not a reason. That's not a reason that something would
If
be
someone
right.
gave
though.
you their altitude numbers,
The ability to
and if
check
someone-
something doesn't determine the truth of a fucking
no, but if
claim.
someone gave you their
idiot.
altitude numbers, gave you their measurements, like you can.
They didn't
start
measure
off with
anything,
the assu-
though.
You could start off with the assumption that they're not entirely lying.
Oh, so you could do it, so it's right because you could check it.
Well, I mean, the only reason you're having like this conversation doesn't make sense.
No,
if I
don't talk
say-
about
if-
me, dude.
If you're lying,
We're
to
talking
me
about
right
your
now,
argument. Don't try to switch
I
it to
wouldn't
me.
be having this
We're
conversation.
talking about
if you're
your
just lying
argument
every second.
that you think it's right because you could check it.
Should I trust you? Why should I trust you?
No. You didn't.
Like,
You're
why
not
should I trust
trusting
anything
anybody.
you
There's
said?
nobody to trust. Nobody did anything,
Then
Donald.
why are you speaking in this chat?
You didn't do anything, Donald.
Why are you speaking in this? Like again, you're just shitting on yourself at this point. Why are you here?
That's a better question. So, Donald,
why are you here?
I just want. So, Donald thinks things are true if he can check them.
No, I'm saying I'm going to default to thinking someone's not lying until
He
evidence.
showed you Google Earth. What's there to lie about? He showed you Google Earth. Why do you
so
think the
where- yeah,
numbers
so
in Google Earth are correct that he's showing?
So what? Yeah. Since when are the Google Earth numbers wrong?
All the time.
What's like? No. Tell me that.
It has to be wrong.
You can make a lot of money off this. I want to hear this because I want to.
Oh, okay. So go on Google Earth. So Donald, go on Google Earth right now and take the path tool. Yeah, I'm going to tell you right now how to do it to show Google Earth's wrong. Take the path tool on Google Earth and draw a circle around the north to south pole. Go ahead.
I
do it
don't
right
have
now.
a computer in front of me. Sorry.
Yeah, but you can do this and it's going to make a half moon. So yeah, it's wrong. Because Google Earth's a cylinder. Because Google Earth's a cylinder, Donald.
Circle and make a half
Donald,
moon.
because Google Earth is a cylinder.
I don't know what you just said.
Google Earth is a...
numbers. What data or numbers are you getting out of Google Earth that are wrong?
I just told you would be the distance of that fucking circle.
No, but like you can't confirm that yourself. You've never measured. You've never gone out and done.
I
that.
know
Like,
if I
what
draw a
numbers can you-
circle
what
around the
numbers can
South
you
Pole,
confirm?
it doesn't look like a half moon to
You've
the
never
east.
traveled around the South Pole though. So what numbers can you confirm are actually wrong? If you were like, when
Yeah,
has it
but
ever been confirmed
I know that
wrong?
a geometric form of a circle.
You know it's wrong, but when have you ever
Okay,
actually measured
dude.
any of it to be wrong?
Because circles have properties.
Because what?
Because a circle has a property.
No, but
And
have
if
you
I
ever
draw a
measured
circle
any of
around something, the thing I draw it around, it doesn't
You've
go
never
outside of
you've
it.
never gone in a circle around the South Pole. So have you ever
No.
measured any data?
We're talking
Has
about
any
Google.
data from Google Earth ever been measured to be wrong? Like
Okay.
you've measured.
Yeah,
them to
I
be
just gave you an example.
wrong. No, but you did not do that. So
A circle is not a.
measured any
Yes, I
measurement?
did do it. Yes, I did do it. I
You
used
went around the
Google
South
Earth and I
Pole?
did it
You
on
went around the
Google
South
Earth.
Pole? You went around the South Pole? If
Bro.
you circumnavigate the South Pole, then I don't know.
Okay,
what we're talking.
slow down. Steel man, what I just told you.
You said that you did it. Like if you
No,
circumnavigate
steel
the South
man, what
Pole.
I told you to do on Google Earth.
Steel man, what you told me. No, you don't steal man what I say. No. Fuck that.
5 seconds. 5, 4. I didn't even give him 5 seconds. That was lame, dude.